All right, let's get a sound check in here. I think sound check sounds pretty good. I think you guys should be able to hear me. I'll pop on stream here. All right, so we're going to talk a little bit about Intro to Cloud Computing today. This is a couple of presentations that I've done before with the group. Also, you guys might notice I've moved my microphone a little closer to me. Normally it sits over here on my desk, but I had some people asking about better sound quality, and I said, well, I'll give this a try. So if you guys like the microphone stuffed in my face, I guess this is what I'm going to do. We've got YouTube up and Twitch, so we've been doing kind of both of them. For some of you that know, I've been in Cancun for the last week, and as I went to Cancun, YouTube kind of, I guess for us, blew up. And the reason I say that is we went from maybe about 2,000 views to about 55,000 views in just those days. So I watched like the metrics shoot up and then slowly drain out because I was down wrestling and doing stuff in Cancun. So I didn't really this is my first time back on. So all right, so we're going to talk about Linux today. You guys know I'm pretty casual on the stream, so if you got questions, let me know. And we're going to talk about some of this stuff. I'm watching both chats. And yeah, so we'll go through it. So this is my Intro to Cloud Computing by Scott Champagne. I originally did this for you guys and talking about, what is cloud computing? What are the cloud deployment models? What does it mean to be a private cloud or a community cloud? And then the cloud service models and some of the security concerns in cloud service providers, some issues in cloud environments. And the overarching concept of this is, what is the cloud, right? And then we'll talk about data security in the cloud in the next part. My background on this, if anybody cares, I've been doing Linux for a long time, and I have a whole bunch of certs in this space. If people care about those certs, you could check the certs command out and all that kind of stuff on the Twitch side. On the YouTube side, I guess you just have to go look me up. But I've been doing this stuff for a while. All right, so whenever we get into cloud, what the heck are these? What's a SaaS? What's a PaaS? What's an IaaS? What are these different acronyms? So we'll talk about this, okay? So what is cloud computing? I have a shirt that says this, actually. What's the cloud? It's just a concept or a generic idea. That's what most people think. Most of the excuse me. Most of the background of cloud actually comes from obviously virtualization, and then before that, jailing users as processes, jailing processes down so they think they're the only one on the server. These concepts are the same things that are used in your phone. We use them in data centers. Back in the Solaris days, before Solaris was bought by, so Solaris was owned by Sun. It was an operating system, and then Sun was bought by Oracle. And Solaris is kind of like something to play with nowadays. It's not an enterprise level tool anymore like it used to be. It was this operating system, was great. And we had these things in there called Solaris zones, where we could partition off different areas of a overarching file system or overarching operating system and give just the libraries we wanted to. We could update one container. They're all called Solaris zones, but it's the same idea of like early containerization and that kind of stuff. So anyway, so the point is, the joke is it's mostly all Linux servers on the back end. This is one of the reasons that the professional Linux users group is so big on you guys learning this stuff, is because almost everything is doing some kind of Linux under the hood. So anyways, that's something to think about. And, I will generically say Linux, Unix together, although there is a significant difference in that space, but not enough for most people to care when they're talking about cloud. All right. Anyway, so the cloud is actually very well defined. So a lot of times as engineers, like if I'm drawing something up on the screen here, or if we're talking about things, in our diagrams, we will go off to the side. Oh yeah, hey, thanks on the YouTube side. Somebody said it's their first time here. Thanks for sharing. Hopefully this stuff's useful to you guys. The whole reason I do this is to let you guys know that we've got a Discord out there. There's a group of engineers that are doing this stuff and want to help you get to be like a professional at this, okay? So if anybody's wondering why I do this. Anyways, all right. So it may come to you as a surprise that cloud computing, it's not this generic idea. A lot of times when we're engineering and we're drawing something, if I don't want you to worry about something, if I'm like, hey, that's orthogonal to the conversation, we don't really care about that right now, I'll just draw a cloud. So like if we're talking about our LAN, and then we've got a demarcation point out to some or some wide area network provider, I may just draw a line over there and then go like this with a cloud and say, whatever. But that's not what's going on in the cloud. In the actual cloud space, we're talking about a very well-defined standard. So the NIST standard is 800-145. So if we go click on that, right? If we click on my little link here. By the way, this is up in the Discord if anybody needs this. If anybody's like, hey, Scott, I need this presentation. Here's the standard. So I'll link this to both the Twitch side and the YouTube side if anybody needs it. All right. So this standard, hold on, I'm going to pull it up here. It's a very short standard, in fact. I'm not going to cover my little closed captioning, so I won't make it so big. But it's a very short standard. In fact, the first 5 pages are them just patting themselves on the back. And then it gets into, I think it's first 6 pages. And then it's the essential characteristics, the service models, and the deployment models. Those are the 3 things that kind of define the cloud. So we'll get into that here in a second. I just wanted you guys to know where I'm referencing a lot of this stuff from, because this is a well-defined thing. This is like a standard that's out there. Okay? Okay, good. So that's the cloud, and we'll talk about the definitions of each of these pieces, all right? And break them kind of out a little bit. So here's our essential characteristics. We want to have on-demand self-service. So I should be able to go and provision things without having to call or talk to a person to do that, right? If I want to get another EC2 instance and stand that up, I should be able to do that. Now, the method that we tend to do that is through API calls. Every interaction that you do in the cloud, every interaction, whether it's, the main 3 that I've used are Google, AWS, and Azure. Those are the main 3. If you go in through a console, which is like a web portal, you're still doing API calls on the back end. If you use a PowerShell or a CLI of some type, you are still doing API calls. And if you use something like Bodo 3, let's say you're using like Bodo 3, which is the Python to AWS one, or you're using any of what we call SDKs, right? I think software deployment kit or development kit, whatever. Any of those SDKs that you're using are still API calls on the back end. That becomes important later when you're going to troubleshoot things and all this kind of stuff. This is why we want to know our response codes and that kind of stuff, so that when we're doing these API calls, we're getting what we expect. If I can't communicate, I need to know the difference between a 400 and a 500 error, right? And I constantly kind of hammer that into you guys on stream here about knowing the difference between them. Hey, guys, over on the YouTube side, I'm just going through essential characteristics here of the cloud. And then we're not getting too much talking on the Twitch side, but that's okay. Normally my regulars will pop up. I'm not normally on Saturday mornings, but I've been gone in Cancun, Mexico for the last week. So I'm trying to kind of catch up a little bit, kind of spinning my wheels down there, watching, I'm watching everything kind of cool off on the YouTube side, going, I got to put something out. But as you guys, anybody that sticks around with our group for a while, you'll find out that I'm not a content creator, guys. Like, that's not what I do. I'm trying to educate you guys on there's ways to get into this field. There's ways to do this stuff. So, okay. So then after the on-demand self-service, we have to have broad network access. Capabilities are available over the network and accessed through standard mechanisms to promote use by heterogeneous thick or thin client platforms. So there's a bunch of ways to access this, and from all different types of places, right? That's what broad network access is. Also, there's also some other components to this where, like, over on the AWS side of things, if you are tired of having poor network capabilities, they only opened this up last year when I finished my Solutions Architect Pro with AWS. This was only early last year that they opened this up, so it would have been like 2023. Where now, if you want to move data globally, you can actually have your data centers connected up to your VPCs, and you can move data over the backbone of AWS so that you're not just moving it over the internet. There are security considerations there. There are maybe cost considerations there, depending on what type of services you're paying for in the different countries and those kind of things. And there's a lot of things to consider there. And you get relatively, it's pretty fair transfer rates of data within the cloud, I think. It's about 1/10 the cost of when you pull the data out of the cloud. So that's kind of good. All right, but we're not talking cost right now. I have other talks where we talk about the cost and stuff. But then there's resource pooling, right? There's the idea that the resources are pooled together, and then because of this virtualization, this ability to do time division multiplexing against a processor and give you some of the processing and me some of the processing, we can get deeper and deeper into cost savings, right? What we call economies of scale, right? They talk about a sense of location independence. And real quick, if we're not doing the virtualization talk, I got a different talk on virtualization, but a real quick thing about this as far as virtualization goes with resources. Let me pull this up for you guys real quick here. These are all the other talks that we do on here. Let me do my intro to virtualization. And again, we're not doing this one right now, but let me move this so that you guys can still see. Let me get this out of the way. Okay, so you guys should still be able to see I want you guys to have the closed captioning at the bottom because sometimes that's helpful for people. But when we get into virtualization, right, you've got all this waste. For every 1 second, well, for every 1 tick of a clock, this is the CPU that's being used, and all of this up here is wasted forever. It's gone forever. You're never going to get it back. And it sounds like I'm being philosophical, like I'm up on top of a mountain or something trying to philosophize about things. No, this 1 second where I used 30% of my CPU was 70% wasted. It's a fact. It's a fact of engineering, in fact. So what we try to do is, with engineering, we try to squeeze more and more out of this hardware, right? That's what virtualization is, right? So we're trying to squeeze more and more out of it. And then if we come here, we'll get into that on another one. But that's what resource pooling is, right? Usually code, but recently started doing something with other people, and I'm sure how to make everything in order, like quality code security. What is the usual strategy? Yi Wid over on the YouTube side. I don't code really. I code like scripting and stuff like that, but you won't find me, like, I'm not a coding stream, strictly speaking. I'm a systems engineering and systems administration stream type thing. So hopefully that answers that for you. And Amit, as far as getting into DevOps, we can definitely talk about that. That's something we talk about a lot in the Discord. So I would tell you, maybe find out, if this stuff's interesting enough to you to hang out down in the Discord, and then I will link. Hold on, let me pull up our Discord link here, and I will drop that in on the YouTube side. So if anybody wants that, there you go, and then you can join the Discord, and that's where we talk about a lot of that stuff. But yeah, we definitely have guys that are pro DevOps and SREs and stuff. All right, rapid elasticity. So I need to be able to span out. Oh yeah, I'm live right now, guys. Yeah. So on the YouTube side and on the Twitch side, I'm live right now. Yeah, I haven't been on streaming for like a whole week because I was down in Mexico. We were wrestling and eating a bunch of food and sailing the high seas, and it was fun. Got real sunburned. I'm real sunburned. We had to use this reef safe sunscreen, which basically reef safe sunscreen just means it doesn't work. So the inside of my legs are all red from laying on the boat. All right, rapid elasticity. This is the ability to provision and release automatically, scale upward and outward. So now when we talk rapid elasticity, we tend to mean that you can scale up and or even deploy new services very quickly. But when we talk about scaling of services in the cloud, a lot of times we're talking about services that are already there, and we can scale horizontally. Horizontally is place more servers. Vertically is make a server bigger, stronger, faster, whatever. And the difference there is like this. There's some services that lend themselves very well to scaling horizontally, and there's some services that have to be scaled vertically. So let's talk about scaling vertically. If I have a database, right? If I have a database sitting there, and most databases are very greedy. They want to hold all the memory they can. They're like, give me all the garbage. Give me all the garbage, right? It's an old meme. But anyway, so they're holding everything they can. That's how databases tend to work, right? And if you were to take a database that was 500 gigs of just holding all the data, and you wanted to scale that up because you were having performance issues, you could not put another server next to it that also had 500 gigs and say, okay, share database. That's not how databases work, right? Hey, how's it going, Tomato? I'm not normally on Saturdays, but I'm just kind of hanging out talking. What you need to do with that database, you need to scale up its resource so it has more, typically memory, but also CPU. So it's got more memory so it can hold more things on the one machine. So that's vertical scaling. That's making a resource bigger. And you tend to have to do that with databases. That's one of the things we do. But things that scale very well horizontally, meaning we just place more instances, are like web instances. So in other talks, we talk about you've got your front-end web presentation tier, you've got your middle logic application tier, and then you've got your back-end database tier. And we talk about this in data or database tier. And we talk about how these things work. Well, the database needs to scale bigger. But the front end, that web, that's just something sitting behind a load balancer. You've got some reverse proxy sending connections to whatever you have. Shit, more web servers are more web servers, right? That's fine. Now, there are some scaling in and some considerations on caching and stuff that kind of come in there. But for the purposes of like a web server, if you have 3 web servers completely at max capacity, adding 2 more web servers and then just having links for people or connections over from your reverse proxy, your load balancer, that scales the service up just like that. So anyways, when we talk about horizontal scaling, we're talking about placing more instances. And we talk about vertical scaling, we're talking about making the instances there bigger, faster, stronger, right? Almost universally databases in that sense. Even most apps, when we're doing like APIs, the application, the service that's running the application, you can have a whole bunch of them. As long as they're writing, as long as you have good ACID database writing, you should be fine. And then proper caching, so the connections are, there's a lot of stuff there that we talk about in other talks and stuff. In fact, I have some labs on that where you build a 3-tier app and then you look at how the data kind of moves through it, right? That's in Kubernetes side of things. And then the last one is, if somebody's going to give you all of this, they have to have a way to charge you. Well, they're not giving it to you, right? They're providing it as a service, and they're going to measure that service. So cloud systems automatically control and optimize resource usage. All of your cloud vendors treat this differently, but there's a few universals that are always true. Putting data into the cloud is almost universally free on the network side. Why is that? Does it not cost the cloud provider to accept that data and put it in your service, your system? Oh yeah, it costs them, but they are okay with that because you're moving out there. They want you to use them. Now, there is a cost to storage, obviously, but the actual movement of the data in costs next to nothing. Most cloud providers, like AWS, for example, charge to pull data out of the cloud. So when you pull data down to your systems, you're being charged typically at a rate of about 8 cents per gig down. And that's a sticker shock for some people because depending on how your work flows, if you've got data center applications running and reading databases and pulling a lot of data down, you can get a huge sticker shock on how much money you're spending in the cloud, right? Pulling data out. But what if I told you that if you just moved your processes up into the cloud and then you maybe move that data laterally within the cloud, you pay about 1/10 of that. So you don't even pay 8 cents, you pay under 1 penny per gig. And that starts to become a lot more kind of tenable for people. Like it's palatable, right? It's like tastes better to the organization if you want to think of it like that. It doesn't. It's within budget if you want to think of it like that, right? Okay. So, anyways, these are the essential characteristics. I took these right from the NIST standard, 800-145, right? All right. So then, service models. These service models, I've got a few things in the future slide deck here that'll help you out with this, but you've got from the bottom to the top, infrastructure as a service, where you still hold the most responsibility, and they basically give you power, space, and cooling in their data center. And then you power, space, cooling, and like networking, pretty much, right? And then you come in and you build, sometimes they'll even build you the operating system. Then you maintain and manage the operating system going forward. That's kind of you. So you have a lot of responsibility here, a lot of things that can be unsecured, a lot of things that if you leave them open, you're not secure in the cloud. That's on you. We talk about that a lot, where responsibility begins and ends, and we'll talk about that a little later on in what I'm talking about today. And then there's platform as a service. Typically, they are going to deploy the operating system for you, and then they'll run it. They'll run the operating system. They'll patch it, they'll make sure that the kernel updates are there and that kind of stuff. So for you, you're going to be responsible for maybe your what we call tier 2, or sometimes we call it middleware. What do you want to put on top of it? And then, but you don't control the underlying infrastructure, right, for that. And then software as a service. This one's the least work for you, the least responsibility for you. They provide everything up to just a web portal. And you have two things typically that you do right here. You set up the system and the identities of your users. Like, how are you going to allow people to use this? And then 2, you securely move your data in. Those are your 2 things. Users and configuration are together, and then your data. So I've got a few models and a few images that'll help with that a little bit. All right. So then we've got our deployment models. You've got private cloud, you've got community cloud, public cloud, and hybrid cloud. And you guys can read that a little bit, but we'll also look at those in a couple of images coming up here. But private cloud is, maybe like my home lab here, where I have the ability to do, where is my home lab? Hold on. XCP-NG. I just got home last night from Mexico again, so I am not even connected on some of this stuff. This is my home lab here, right, inside of XCP-NG. Let's see if I can connect to my devices. Are my devices actually up? Ah, there we go. All right, so I've got devices here, and these are my servers that sit behind me in my little half rack. And then if they're turned on or off, and whatever we're doing with them, right? Different servers doing different things. But that's kind of like my own little private cloud. And people have access to that from our Discord. I have Apache Guacamole, where people can get in through their browsers and do different stuff up there. In fact, I'm going to be working with the guys to get like a provisioning method for people that want to use like an hour or 2 of resources and get in there and do some of these labs, because I want people here to that stop by. Habbo, I've not used OpenStack. I've read about it. We were looking at it back when I was at AAA a long time ago. Well, a few years ago anyways. But I haven't used OpenStack, no. I've read about it, though, quite a bit. But it's kind of like your own internal private cloud deployment type thing, yeah. The managers I tend to use, because I'm on the high-performance compute side, is like Werewolf and XCat. So Werewolf or XCat. Let me pull those up real quick in case you guys haven't seen those. How am I going to do this? Hold on. So, whoops. Pull this up here. Werewolf. Yeah, there we go. So Werewolf is kind of the same thing as like a Beowulf type setup. And it's cluster management provisioning, so I'll link this over to you guys if you need it. So here and over here. And then also the other one that I use, and this one's not being supported as much, is XCat. And XCat's big on the high-performance compute side because of its ability to deploy over IPMI and BMC. So there's some really powerful things. Windy Force, she said, do I give free advice on how to create a lab with Proxmox? I know I can find it on YouTube, but there's more specific to planning a home lab diagram. Yeah, Windy Force, I will help with anything like that down in the Discord. And the reason I say that isn't because obviously I want more people in the Discord. We got like 1,200 people. It's getting pretty big. But no, more the reason I say that there's a lot of people that have set up Proxmox. I've never set up Proxmox. I use XCP-NG. Where'd that thing go? I use XCP-NG, but we have a lot of people that have done that, so you can get a lot of good answers and a lot of help down in the Discord. In fact, if you search for Proxmox in the Discord, you'd probably see us talk about that over the years, just because that's the thing. But yeah, we can definitely help out with that. It's just that would be more of like an offline thing. And the other reason I tell you guys so much about the Discord, I don't get anything from Discord, right? It's just us hanging out, talking shop. Is I can get you guys, one, more with like the different experts, and 2, it's more persistent. Here, even though people can talk to me, it's kind of very one-sided. But yeah, Wendy, you're definitely welcome to hang out down in there. And we've had a lot of people over the years they've tried to get me to change the Proxmox. I just haven't wanted to build the whole lab over again yet. You guys will find. Oh, and then I've got all kinds of monitoring in the lab. I don't even have any of my monitoring up right now. Let me pull this up here real quick. Also, yeah, thanks for the follow over on the Twitch side. Let me pull up. I don't even have my home lab up right now. Ever since I got back, we haven't set up any of this stuff. So hold on, let's get me in my home lab real quick. There's Ranger. Ranger's good. He was safe. Discord URL. Yeah, just type in / Discord on the Twitch side, and it'll do it. For the guys on the YouTube side, you gotta. I don't have a good way for you guys. Let's see. This is home lab. How's the home lab? What? I got something down. Something's down in the home lab. What's down? Hold on. InfluxDB is up. Prometheus is up. All right. Well, now I got a problem, but I'm not going to go squirrel away and chase that problem right now, even though I want to. For some reason, as I get home, all of my monitors are down, but Grafana's up. So now I got to go figure out where my stuff is broken, right? And that's fine. That's something we'll do later. Also, it's funny, I haven't been in a command line for Linux for a week almost now. Let's hop in the home lab real quick. So here's my internal home lab, right? Get up the user. Oh, that's not the right password. All right, so now we're in. We do a screen-R to get back to our old screen session, right? Because we've had this system up for quite some time. We're over in our screen session now, and then let's check something. So look at our hosts. This is my host in my environment, but on the Linux side now, right? Manual QA looking for move into DevOps. Learning more about home labs. Linux has been a lot. Appreciate you taking time out to teach. Yeah, Knux. Yeah, Knux. Hopefully this stuff's useful to you. Yeah, we have a lot of stuff going on. Yeah, absolutely. Windy Force. Hopefully this stuff's useful. Let's go check a couple of our services because I don't know why everything's down. So we haven't filled up root on this, so that's good. Prometheus is running. Okay. Let's go check InfluxDB. I think I called it Influx 2 when I was looking at it. All right. We've went off the beaten path for a minute. InfluxDB looks like it's running. Does not look like I filled up its directory, so that's good. Okay, so if my data is there, then why is it not showing here? Interesting. We've got. Oh, hold on. Wait, did something restart? So this is another thing. Let's go. It's been up 123 days, so that's not the case in this one. This one's been up 123 days. Let's check is it listening? So it is listening on port 9090, so that's how I communicate to it, right? I see you have a lot of nodes there. Will having a mesh from ISP be useful in this case, or a powerful router, or not needed at all because it's virtual? Windy Force, it doesn't matter because it's internal. So I have a networking primer on this, but like internally, you have almost an unlimited use of the addressing spaces that are non-routable. So you've got the 192.168, the 172.16 range, and then the 10 range. So you have literally millions of addresses internally you can use, and all of those devices, if they want to communicate out, they just use NAT. And then some of my devices are actually in their own network off to the side, and then they have to be routed over. I have an architecture on all that stuff. But yeah, it doesn't really matter that much, Wendy. But yeah, the answer to that is if you have a lot of internal and you only have, like, let's say one external, that is a port address translation, or what's called a NAT overload. And it's network address translation, where when it goes out, it gets assigned a different port number. That's all it is. So then you can have network address translation to a bunch. But internally, they all talk to each other kind of like by their first name, if you want to think of it like that. Okay, well, guys, I'm going to troubleshoot that later because we're still talking about this stuff. So you guys will find out that sometimes I go far afield when I'm sitting here talking. But yeah, thanks for the follow, Jabo Jangos. Hopefully this stuff's useful to you. All right, so let's talk about the deployment models a little bit. Private cloud. One person owns it. This one person can be me. Let's say it's me, and or one organization. And a private cloud just means that whether it's here in my home, or if I'm doing it in a data center, like maybe I'm paying rack space. This was a big popular thing in the early 2000s. We would pay companies to just give us a rack. Just give us a rack. I'll go put my computers in it, and then I'll lock the rack. That's it. And then sometimes we'd give their data center technicians the ability to reset things or those kind of things. But for the most part, that's what a private cloud was, right? Single organization, right? Maybe owned, managed, and operated by an organization or a third party or some combination of them, and it may be on or off premise. Those are all part of characteristics of a private cloud. So it's me, and I own a cloud somewhere. That's it. A community cloud would be like if me and maybe I'm a dentist's office, and then I have other dentist's office around me, and we decide, hey, we're going to pool our money together and get start maybe our own little even company between us, and that company will run the cloud for us so that we can be maybe in HIPAA compliance. It can be our own, one of us running it, or some third party, and it may exist on or off premise at one of our locations. But the point is, multiple of us use that one community cloud and we own it. That's a community cloud. Kind of gets a little bigger than just a private cloud, but you're typically doing it to save money in like the HIPAA space, or maybe Sarbanes-Oxley, definitely PCI DSS, which is a standard in the industry about taking card payments. And when you're trying to adhere to that standard, it can be expensive for you as an organization. It takes a lot of work to be PCI compliant, which is one of the reasons small businesses will pay 2 to 3% or something for card sales through like Square or one of these other tools, is because they'll go do all the PCI stuff. All I'm being is like a transaction endpoint for whatever I want to sell. Now, it does cost you like 2 to 3% a transaction or whatever it is, but that's a lot cheaper for smaller businesses than trying to go be PCI compliant. And PCI compliant, that's a thing that I've done a lot in my career, PCI DSS standards, but it's not difficult. It's a lot. It's just a lot of time. And if I'm sitting over here trying to sell my widgets, or I'm sitting over here selling flowers in a flower shop, I don't want to worry about my servers being PCI compliant. That's not it. I want to have some third party do all that for me. Which, by the way, is one of the reasons the cloud is so powerful, because you can have all your systems PCI compliant by default. Now, what you run on top of them, you still have to maintain your own compliance, but the underlying pieces that you're given are all compliant before you put them together. So, all right, we'll get to that. Public cloud, this is what you normally use with AWS, Azure, Google Cloud Platform, Alibaba, like the big ones, the big players around the world. Oracle's got a big cloud, and IBM's got a big cloud. Not a lot of people think about that, but they have huge cloud service provider. They're huge. But that's a public cloud. This is what we go to when we go like AWS, and then we log into a front end, and we build ourselves a virtual private cloud out there. We are using the public cloud at that point. Public cloud shared by multiple companies. So anybody can use those resources in the way that we described up here, right? On-demand, broad access, resource pooling, rapid elasticity. Now, some of these things, like there's things we can do inside of these to say, well, I don't want to pool my resources. I want to be off on my own resources. I have a compliance standard that says I can't have virtual machines with any other ones. You can do that, but it's going to cost you more, right? To have a whole server dedicated to you and nobody else is allowed to be on that host, right? That host that has all the the guests on it, you can do that, but it costs you more money, right? All right, so anyway, so we get down here. Then there's hybrid cloud. This is kind of the one. I don't think I've ever worked anywhere that wasn't at least at this. And what this is, the idea is you've got traditional infrastructure still. You've still got your physical stuff you're doing. And then you've got your private cloud, maybe, that you've been moving into and playing around with. And then you've been moving out to the public cloud. And I always joke around that companies are in one of three areas here. They're either moving more to the public cloud, AWS, Google, or they're mad about it and they're using it, or they're moving back out of it. Because there's a lot of stuff that's been even in the news recently about like, hey, you shouldn't be just out in the cloud, And this is one of these concepts of we talk about vendor lock-in and vendor lock-out, and those are different concepts. But the idea and the old adage is don't put all your eggs in one basket, right? If you're in the public cloud, that's cool, but if you only build stuff in US East Region 1, which is the biggest AWS region and where all the new stuff is, well, what if, and then inside that region, you only build in one availability zone. You don't build any redundancy into your stuff. And then, maybe within that, you don't even build in different subnets. You build everything in one area. Well, do you understand that when you do that, if that availability zone ever goes down, you have a potential to lose services. You have all these things. So one of the things that they kind of constantly talk about if you're doing any of your cloud practice or you're doing it practically and working with solutions architects is you're not putting everything in one place. You're spreading it out. You're having redundancies and these kind of things. Well, a lot of organizations are doing that same thing. So they'll keep some traditional architecture, some traditional infrastructure, and they can run what they need to. And then they do this thing a lot of times called bursting into the cloud. We do this in the high-performance compute space a lot. We have, in high-performance compute space, the value is still on owning the equipment. And one of the main reasons for that is because the speed of the networking that we can get with like high-speed InfiniBand type switching is way better to just own that and to move that data around than to do it up in the cloud where you'll never own it. You'll never get the performance in the cloud that you will on those low latency links and link aggregation groups and stuff in your high performance compute. And let's see, you'll never get the speed, you'll never get the performance, but then you're also going to be paying for it every time you move data, which is kind of wild. I really like how Blizzard does it. Private data centers running OpenStack, which auto scale out to public cloud. Yeah, Q, that's actually being able to burst up into the cloud, and then when you're done, you just rapidly scale it back in, which, by the way, is right there, right? Rapid elasticity. I can move out to the cloud, I can move back in. And my organization that I work for, Redline, we actually did a thing a while back. Let me see if I can find it real quick. Hold on. Let me pull up here. Redline. Get my hands in the right place. They had a case study that they did a while back. This is dated a little bit, but it was production supercomputer. We were trying to move some HPC stuff from NOAA, which is National Oceanographic Atmospheric Agency. We were trying to move some of their workloads up to the cloud just to see what it would cost and like what kind of speeds we could get on the workflows compared to the Dogwood and Cactus supercomputers that we had just built, right? And this was not one. Hold on, let me see if I can find production supercomputing. I think it was this one. No. Well, anyways, there's we put these out. It was a while ago. Is it getting cloudy? Oh yeah. So this was it back in 2021. Okay, this is one of my colleagues, Chris Young. I helped edit this. I didn't write this. I helped edit it though. This is, if anybody wants it, this is an organization I work with. Let's see. Flight said, I'm just getting started working with the cloud AWS. It's good to build a region availability zone as I build a working project before scale. Oh, flights. Absolutely, you can do that. Yeah. And also, if you guys don't know, we actually, a lot of us in our professional Linux users group either work directly with AWS or some of our guys work for AWS. So if you go down in there and you start posting our little golden jacket stuff, because we got a few of them, we were joking around about getting all 12 of the AWS certs at one point. I stopped after 5 I stopped after I got my Solutions Architect Pro, just because I wasn't really working in that space much. Although I might be doing them again. One, just to kind of keep it going, and two, because I'm teaching more cloud stuff at the college, so I want to do that. Oh, Q, that is actually a fair point. Q said the requirement that the U.S. government levies for secure cloud computing are cost prohibitive for any organization that can't print money. Yeah, it's expensive out there. Let me see if I can find. Hold on, real quick. Yeah, in this talk, what we were doing, I think they moved this out to Azure. They didn't do. Yeah, they did Azure, and then they used Lustre out there, and they just wanted to see some baseline speeds and what the raw network that they could get out of it. And then they did some performance testing, right? So there's some stuff in here. It's kind of hard to read there, but I don't know why that's blurred. But they had these numbers out there, and you can go read about them. But if you guys are data-driven people and want to kind of see what kind of some of the speeds were like, and that was in 2021, so like you're getting better infrastructure things nowadays as well. All right, this is gonna bug me. Why are my data sources jacked up? Hold on a second, guys. I'm gonna go look at my data sources that are there. So why is my data source down? Save and test. Network error, bad gateway. You know what? Hold on. What if it's Grafana's problem? Oh, whoops! Don't want to question at the end of that. What? Let's find our Grafana. Oh, it's Grafana server. Okay, so let's restart that. Let's give it a second. Do a status on it. Right, so it's back up and running. And then we do a system. We do an ss-ntulp, and then we grep for Grafana, and we make sure that it's listening on port 3000, right? lsof-i for port 3000, and we see that Grafana is listening. Good. It's very possible that this was a timing issue as things came up. So I suspect right here that if we refresh this, no. Still bad, huh? Ranger cam's good, though. Ranger's not moving around down there too much. All right. So let's go back here. So that's our hybrid cloud. Now let's go into our service models. So here's how service models look. Traditional IT, everything's your responsibility. As you move right, less and less of the things are your responsibility. However, I'm going to tell you guys, I have a problem with this right here. Data is always your responsibility. Like, you are always responsible for the data that you load into the system and how you load it. If you properly use TLS to move your data in a secure fashion, if you don't, how can you be mad when somebody sees your data? You didn't even bother trying to secure it. You know, it's kind of silliness, right? All right, anyways. So here's our service models. On the left, you're managing everything. If you're using infrastructure as a service, sometimes they'll build the operating system, but then you maintain it. And when we say you manage it, you add more software to it. You remove software to it. You could add local users. You could patch the operating system. You can set new baselines. You can build new kernels and compile software down on it. That's yours. It's your operating system up. Middleware is like, middleware tends to be like if you build an operating system and then you put on that operating system like Apache 2, right? You build a web server. Boom, you got a web server. Or you put MariaDB. Boom, you got a database, or Postgres. You've got whatever those things are. A lot of times we still kind of call that tier 1, right? But now when you take that web server and you put Apache Tomcat and then you start running Java on it, that's your Apache Tomcat here, and then your runtime, and sometimes people don't break these up. This is what a lot of people call tier 2 or like middleware. So, you know, you put your Apache on there, it's still kind of down here, and then it's, you know, you put Tomcat on there so you can run Java. Then you've got your Java runtime, whatever version of runtime. Again, if you don't update your Java when things start to come up as CVEs, common vulnerabilities and exploits, in the CVE database, that's on you. It's not on them. They're not managing this operating system. It's on you. So if you go, like, so if 3 years ago I deployed a Red Hat 7 server and I have never once logged into it or touched it since, is it the cloud provider's problem that I haven't updated it and I get it compromised and then I'm running Bitcoin mining and stuff? That's on me. Right? I'm the one paying for that, and rightfully so. There's this guy who said, this is a kind of famous guy. I'm going to pull up this talk real quick for you guys. I did this talk a while back about incident management, and we'll talk about this in another talk another time. Where's my incident management? Not general troubleshooting, but it's not Ansible moving towards automation. It's security. Where's this thing? Cybersecurity incident response right here. So hold on. I'm just going to pull up this one thing for you guys. There was a guy who, his name was Richard Clark, and he was in the, for people that care about the politics side of things, he worked for Clinton, then he worked for Bush, then he worked for Obama, and I think he got out during Obama, but he worked for multiple presidents, and what he was kind of like the start of the Homeland Security kind of thing. But he had this famous talk that he gave in the early 2000s because people never used to really care much about security, and he used to say, this is what he told the people at this big national convention. I need to go find what national convention that was at, because this is on video somewhere. But if you look up Richard Clark famous quote, you'll probably find this on YouTube. But he said, if you spend more on coffee than IT security, you will be hacked. What's more, you deserve to be hacked. And that's the same idea of what I'm talking about in the cloud. If you go in the cloud and you deploy resources, but you then just leave them open and don't follow any best practices and never patch your stuff, I mean, who can you blame? It's you, right? It's your own fault. So that's where I'm going with that. As you move more to the right, it's more and more your responsibility, less and less of theirs. Now, I'm going to ask you guys this. I want you to think about this. As you're loading the data up, and like I said, it's always you for the data. Are you ever going to hear in the news that, AAA and AWS lost your data? They don't care who the cloud provider was. AAA lost your data. So you are always responsible. The cloud will never actually no provider will actually take responsibility for the actual data that you're loading. Now, they're talking here about they'll secure the data and the movement inside, but when you load the data, that's on you. Tomato, he says, cool that I have a Terraform cert too. It's as easy as I say again, take mine Tuesday. Tomato, I don't think that the Terraform cert was hard when I took it. There were 9 areas to know from. And then Tomato, if you go look in our search channel, I have a whole bunch of stuff that I used, but I found one really good like Medium article that a guy put together, and it had like 250 questions. They were not questions from the test. So look, guys, I'm not telling you how to go cheat. What I'm going to tell you is, though, what he found, what this guy did was he wrote out, like, from each of the points of like each of the domains, kind of, because there's 9 domains or 9 areas. He said, if they ask you something like this, these are the types of things that you want to know. And it was a really good little article. So that's up in our Discord. Actually, I did let my Terraform lapse. I had to retake it by, like, I think November of last year for it to keep going. So I don't technically have a Terraform cert right now, but I did have it. I could go take it. Tomato, I did think it was kind of one of the easier certs, but it will get you if you're not ready for it. So make sure you're ready. I know it's only about a $70 cert, which is in my tiering of certs. $70 is in the low tier. That's pretty cheap. My mid-tier certs are in the hundreds range, maybe like 300 to 700, and then the anything higher than 700 tends to be my what I call expensive certs, because it does. There are some really expensive certs out there, but Terraform and Vault are pretty reasonable to get as low-level certs. And also, we have a few guys that have taken Terraform certs recently, Tomato, so if you ask in the search channel, you might get some people that can tell you a little bit about it. Okay, so those are our service models. Here's another way. I like to show this because I think that there's a million of these little images online like this, but pizza as a service, right? It's the same idea, but you have more and more responsibility as it goes to the right. I don't think I have to explain any of this to anybody, but I will tell you, where do your hands get washed there? It's always on you. It's always on you to wash your hands and to know this stuff. All right? So you gotta know and understand how to load your data up and that kind of stuff securely. All right, cloud security concerns. So let's talk a few concerns that are out there. And this comes from the CCSP. So if you ever take your certified cloud security professional from ISC Squared, this is how data flows in the cloud. It's different in the cloud than it is in the enterprise, because in the cloud, you don't have control of the hardware anymore. I can't go put a screwdriver through a disk like I used to be able to in my data centers. All right, Traffic King asked question, do you think that companies will switch from Terraform to OpenTofu because of the acquisition by IBM and the licensing debacle? Traffic King, I have a problem. I mean, I have a problem with OpenTofu anyways. Like I was telling people about this a little bit. My problem was people are going to switch over to OpenTofu, but they're probably still going to be using the same providers. And then they're still going to be using the HashiCorp language, because all that stuff's HashiCorp language under the hood. So I feel like it's almost like they pretended to break up, but they're still holding hands the whole time. So I think that, Traffic King, I think that was already happening before IBM got them. But I'll tell you this, if you guys have been kind of keeping up on the HashiCorp news, what happened was August 5th, I think, of last year, they put out the business source license change. So now they're no longer open source. None of the tools under HashiCorp were open source. They're part of what's called the business source license. Well, but the code is still out there. So there's this idea, OpenTofu forked off of the open source code. What happened was, as they keep writing the code on the Terraform side through HashiCorp, it's still out there and available. So OpenTofu, about a month or two ago, it was only a few months ago, they got a cease and desist from HashiCorp saying, hey, our business source license code is ending up in your new, split off open source. And they're like, oh, hold on, we've been doing all this stuff to stop it. And then there's probably going to be, actually, I'm going to promise you there's going to be a lawsuit now that IBM owns them, because can I show you guys something that happened? So I used to work in the I still work in the high performance compute space, but I used to work heavily with IBM and Platform LSF. So they have Platform LSF. And let me show you guys what happened when Platform LSF was bought by IBM. This mirrors in my mind exactly what's going on with, hold on. This mirrors exactly in my mind what is going on with them. So watch this. So look at OpenLava. Here's I'm going to posit this for you. And I think that organizations are going to move away from it. This is to answer your question. But OpenLava was a split from LSF when it became Platform LSF as IBM picked it up, right? And what happened was, so look, in 2007, Platform Computing, part of IBM, released Platform Lava. Okay, so in 2014, so they founded this company called TerraProc, and what happened was they got the shit suit out of them until they ceased to exist. And the reason they got the shit suit out of them is because code that had been in the proprietary side of IBM's Platform LSF was found to be over in the OpenLava. So they got caught up in this forever. So, guys, the reason I bring this up isn't because I want to talk about controversy. I'm just telling you, the question was, if OpenTofu and Terraform are sitting there, and OpenTofu over here is a fork of Terraform, which is now owned by IBM, and code from Terraform's business source licenses showing up over here in OpenTofu, this is the exact thing right here, guys. Hey, Robodom, can I ask you a big favor? If you're also on the YouTube side, can you take that link and drop it on the YouTube side as well? I don't know if you mind doing that. But do you guys see what I'm saying? Is this is like history repeating itself 14 years later or whatever. Actually, the lawsuit happened in like 2014 because I was literally working with IBM stuff when this happened. Robodom, I moved the microphone way closer. I used to always keep it over here to the side, but I had some questions about the quality. So I said, you know what? Moving it right here. So Robodom, I have no filters on my voice, so if it's deep and sultry, good. If it's not deep and sultry, I can't help it. But it is, my voice is, I'm way closer to my mic. I also have a little, but I bought this a few months back. Yeah, ASMR. I'm just sitting here going, this is how we do our engineering on the late night spectrogram hour. Okay, I don't know. I don't talk spectrograms on here, but if people want to talk radio frequencies, we do that in different places. All right. Okay, so look, Ranger has literally not moved all stream. By the way, guys, Ranger did not stay here while I was gone. He stayed at my brother's house about a mile away. But there's that. Anyway, so that's what, guys, that's what I think is going to happen with OpenTofu. I think that project doesn't have long with IBM over the top of HashiCorp. So, and that's why. Is historically, that's exactly what happened with OpenLava and Platform LSF. Same exact thing, same exact accusation was just leveled about 2 months ago, and IBM has all the money, and they don't give a shit about if people think nicely of them. They just care about making money, which is, in fact, the definition of a corporation. So can't blame them for that. That's why they exist. But anyways, let's get back to stuff I know, not things that we can speculate, right? I believe the acquisition of IBM was a power play to acquire mostly government agent customers. Yeah. By the way, HashiCorp Vault was very, very used in government and academic spaces, even if people didn't know. So they haul out the company and make it more geared towards government agencies. Yeah, trafficking. And I wonder if the business source license from last year was part of the talks. Because a lot of times when a company comes in to buy another company, they're in talks for quite some time. So I kind of wonder if they were positioning themselves last year for the purchase. But again, I don't know any of that stuff, so I can stick to things I do know. This is the cloud data lifecycle. We create data. Creating data can be me going and hitting an API and pulling down data of some type. Then I store the data. Creation and storage can often happen at the same time. I create the data, I move it into a pipeline, I move it over into Amazon Redshift. I create the data, I move it generically into an S3 bucket, and as that happens, I log over the metadata of that transaction into like a DynamoDB table. So then now all of my stuff that needs to do any, and then maybe I have some SQS messages going, but anything that's reading and querying can go hit the DynamoDB real fast and will only access the data out of the S3 bucket if it has to. So these are the kind of things that we have to consider and think about. And you might say, well, Scott, where would you find these architectures? Like, can we talk these architectures? We used to talk quite a bit about solutions architect stuff. But if you say, Scott, I want to get more into that, and how do I get into that? Well, one, you start studying your solutions architect stuff. And two, this is a huge place to go. You go to your AWS secure architecture. What is the name of that tool? Reference architecture. Yeah, I couldn't remember. It's called the AWS reference architecture. And you come in here, right? And then you can go to right here. You can just go down to patterns or whatever. But all the things that I was just describing, let's say I wanted to say, I don't know, Internet of Things, and I want to have a bunch of data coming up. And I just want patterns, right? I just want patterns. And somebody will help me ingest IoT data directly into Amazon S3. That's what I was just talking about, right? And then I should get an architecture here somewhere. Hopefully in the summary, the person will give me, here's a nice little architecture. Here's my sensors. There's a temperature and there's a valve. And they're going to feed into an MQTT local broker. MQTT is just a way of moving messages, right? It's message queue something, right? I don't even have to know what that is, right? But I'm moving data over. There's a Parquet, which is a type of file format. Processor, stream manager, throws it in S3 buckets. This can be, even understanding this can be the start of getting into like data analytics, if that's your thing. There's all kinds of pieces along the pipeline that people need to understand and be good at, right? I got a buddy he's built his whole career on like Google Analytics and pulling data in to give over to his data scientists and stuff. He works for a pretty big web service company. He's down our Discord, and he comes and talks to our group every now and then. And this is just, come in here and find the things that are interesting to you. Watch, then I can get out of here and go, you know what? That was a little bit too much for me. I want to learn about this IoT green grass or whatever. Or maybe I want to learn about monitoring, logging, and security for my environments. How do I make these things move data securely with certificates, right? X509 type stuff, right? Front end, web, and mobile. I want to get in here and understand how to get multiple AWS accounts with a single email. Whatever, I don't know. All this thing. If I want to build an app, there's all kinds of architectures out there. The cloud. Look, one of the things about a private cloud that they want you to use it. So they want you to be well aware of how to use it. In fact, I think they're very fair about how they teach you how to use this stuff. All right. So, by the way, we got 9 people on YouTube. That's the most we've ever had by far. Also, for some of you guys that don't know, I've been in Cancun for a week, and last night was my first night back, and then back today on stream here before I teach some college classes to catch up because I was gone, so I didn't run anything. But yeah, we kind of blew up. We had one video that had I don't know, it had like 50,000 views already, so that was kind of cool. And it's funny because I was in Cancun and I couldn't really get a lot of data, but I was watching the numbers go real high and then slowly like cool off, and I was like, well, that's fine. I run my house on MQTT, push all kinds of events and commands to remote devices, and hit them from home. Nice. Lacerated, yeah. That's one thing I haven't gotten into as much as I'd like to, lacerated, but be able to control my energy usage. Like when I was gone, I just turned my house up to like 78 the whole time I was gone. But it would be nice to be able to be like, hey, there's nobody there. We can move it up a little bit. Yeah, Robodom, it's cool. Well, so Robodom, you're part of the Discord. You've seen the Discord just blowing up. And then actually about a day and a half ago, it stopped. And it's because I had only put a Discord link on the YouTube side that was 7 days. So I think people were hitting a link that had expired. So I fixed it this morning because somebody asked about it. But then people started showing up again. So, hey, I don't care how we find the engineers that want to do this stuff, but I want people to come and do this stuff because I think that anybody can do this. Yeah, general channel, Robodom. Yeah, the Discord bot that Fisherman wrote has been really busy. So, yeah, we've got some stuff coming up, and I want you guys to know that the stuff on Discord's always going to be free. There's like a little monetization button. I don't think I'm ever going to hit that because I want people to feel like, hey, you can come in Discord, you can ask questions. It's not about like, oh, you're so dumb you don't know that. Like, I've told all the engineers in there, especially like the Prolog engineers, the guys that have been there a long time, I'm like, look, do you remember when you didn't know anything? Would you have liked somebody to talk to you like that? Like, we want to like build these guys up to do this so that they can take it over when it's time for us to be done with our career. So that video, yeah, Flight, I think it was the name too. It said beginner to expert Linux, and I think that kind of blew up. But then I decided the other day, but today I put it on there. We're just going to call it like beginner to enterprise, because I tell you guys all the time, it doesn't matter if you're ever an expert. Being an expert is kind of irrelevant. Being a beginner is where we all start, but I want to get you guys up to doing enterprise. So this is beginner to enterprise now. I want you guys to like know that you can do this stuff. Fisherman's bot will insult your intelligence if you ask him. But it's also an AI bot, and he has a lab that teaches you how to do it. So if you guys are like, hey, I want to build a little bot like Fisherman's, he's got a lab that'll get you started, and then he's actually come in and done a talk with us before on how to run that bot like that. So we've got a little bot in Discord that you can do an exclamation mark and ask it anything you want, and it'll go out and do that stuff. And he trained it and worked on it and all that stuff. Videos how I found you. Nice. Okay, so back here, as we create and store the data, that is when the data gets encrypted. We do a create and a store at the same time. The data gets encrypted as it gets put at rest. We use a thing called an envelope encryption. I'm going to break that down later. An envelope encryption, and we use at the bare minimum AES 256 encryption. AES 256. There you go. Boom. As we unpackage that data and use it, and then we move it around and share it, the data must be encrypted in motion. The minimum standard for that is TLS 1.2. It's a minimum standard that should be used for moving data. And we talk about that in that other talk that I have coming up here. I was going to try to get through 2 talks today. If we don't get it all on this one, we'll just do it on the next one. But again, this one's called Beginner to Enterprise Cloud, right? Like we're talking cloud stuff. Once you've used and shared it as much as you need, you archive it, store it for either your organization's minimum standard. I need to keep this for 5 years in case I ever need to go look at it again and see some user information. Or for regulatory purposes, I work with, maybe if you work with taxes, what's the minimum you have to in America? I don't know what it is in America, but minimum is I think I have like the last like maybe 15 years of my taxes. I keep everything, and I don't know, like how long do you keep that as a business? Well, that's something to think about. And then after you've archived it, how do you destroy it, right? And there's a thing we don't control. Again, I can't go take a JBOD, just a bunch of disks, and pull the disks out and then put a screwdriver through them and then melt them down or throw them in. Have you guys ever seen those little grinders that you just drop it and it just grinds the hell out of it and just throws metal sparks everywhere, and you've just got like paper mache of like your disk drives? I don't have one of those in the cloud. I don't even know where those disks are. If somebody went to the cloud and pulled, if I could get AWS to send me all those disks, I still wouldn't know that they sent me the right disks. What if they just lied to me and sent me 6 brand new disks because they wanted to keep my data instead? I'm not accusing anybody of anything. I'm just saying, how do I know? I can't be guaranteeing anything. So since that's the case, we must use what's called cryptographic erasure. And to do cryptographic erasure, you have to delete the keys. When you delete the keys, and the data is now just an inert blob of massive data sitting there that's useless to anybody, that is considered cryptographic erasure. Okay? So this is the cloud lifecycle. If you ever take a certified cloud practitioner test, you will have questions around this. Delete public and private keys. No, Robodom, it's you delete what's called the customer master key typically, or just for that data, you'll have like a data key. You delete the data keys. And that actually brings up an interesting point. If you're letting the cloud provider generate those keys for you, you have no actual proof that they haven't stored them off somewhere else, even if you delete them, which is why some organizations must use a HSM, a hardware security module. And then that makes it a certain like FIPS 140-2 compliance and that kind of stuff. Yeah, Robodom. So it's different, slightly different keys, but same concept though. All right. So that's security. And then so now let's talk, since we're talking cloud, right? But I'm going to step back for a second. This is the defense in depth if you're running a traditional on-premise facility. So I tell you, hey, Robodom's the manager of my my data center. Robodom's the manager of my data center. He's responsible for security. So if I went to Robodom and I said, Robodom, in the confidentiality, integrity, and availability CIA triad, what's the most important thing that you can do to protect our server equipment? And Robodom, as a security facilities manager, is going to look at you and go, I could lock all the doors. I could close all the windows. I could make sure I have redundant power, space, and cooling, all that kind of stuff. And I can protect and make sure that users can't just walk in here and walk off with the equipment. And that is actually, in the on-premise space, that's the most important thing. Make sure users can't get to the equipment. So that might sound a bit silly, but it's true. If you do your CISSP, they talk about how high the fences have to be. And they talk about how the shrubbery around your place needs to be carved down, and the lighting needs to be restored so you can see that nobody's up against the side of your facility. That's all important stuff for physical security of your data center. If you have, again, a data center. Then, defense in depth is this idea that we always expect at least one or many of our controls to fail. That always happens. There's no time in which you're not going to have something failing. By the way, guys, also, it looks like we're up to like 14 viewers on the YouTube side. So it may be that YouTube actually has more people here soon than Twitch, which is funny because I've been on Twitch for like 3 years and I just never really got super popular, and that's fine. That's not a big deal. But it would be funny if the YouTube side kept going, and then I'd be like, F you, Twitch. No, I'm just kidding. I wouldn't do that. As long as people are down in Discord, it doesn't really matter. You know where to find me. Where I work, you've never seen the systems I use. Yeah, Last Raid, that's probably true, and you won't get in there if you don't need to. You don't need to, yeah. So then we got our network. So at our network, after we keep people out, we want to keep them out of the network. We want to have layers of access, layers of where things can go. Maybe we have a DMZ where there are things that can communicate out to the world unsolicited. like our web servers. A web server needs to be able to be connected to from anybody. But a database server, database server shouldn't be connected to from anybody unless they're supposed to. One of our pools of web servers or application, typically application servers talk to them, and the web servers talk to the application servers, right? But that's our network. And then at our host level, if you manage to compromise a host or compromise a user on the host, that should not give up the whole system. Like if I'm running maybe some Node Exporter or Prometheus or something, and you compromise that device or that process, you should just be compromising the Prometheus user or the Node Exporter user, whatever your user is, and you don't actually have any other power on the box. You could just like kind of scrape around and look at some processes and stuff, but you can't really do much. Then if you do compromise an application, that application should only be decrypting data as much as it needs to see what it needs to, and only showing people what it needs to. A lot of the times we talk about this where we do a concept called masking. And masking needs to hide your data in such a way that even if people had other relevant data, they couldn't figure out what was being masked. That's kind of a common thing. You can't like I can't look on like masked data and here I mask out like an address, but then over here in a different table, I have like that bullshit number that you assigned a patient ID, and I have a patient ID as a primary and a foreign key, and then I come over here and then I can figure out what their address is from that's not a good masking, right? Hey, how's it going, Monkey Man? We're just hanging out, talking shop. I don't normally stream Saturdays, guys, but I've been gone so long that I wanted to hop on and do something, right? Give users specific authorization access specific systems. Absolutely. This is another one that's really big is if somebody's working in a call center and I have to call in and do something with a credit card, why should they ever see anything but the last 4 digits of that credit card? Like if the system has already, let's say, authorized that I am who I say I am, they've that's not authorization, that's whatever the first one is, it's I don't know why I'm drawing a blank right now. But right, they know that I am who I say I am. That person might say, hey, can you verify your credit card? And then you just give them the last 4, and then they go, okay, good. Yeah, authentication. Yeah, I don't know what was going on. Like my brain stopped working literally as I tried to go left of that A. I couldn't see the authentication. I saw authorization and accounting. I couldn't see the A to the left in my brain for some reason. And that's what happens when you get older, guys. So we configure and harden all devices. That's important. And when I say harden, that means close down stuff that shouldn't be there. Yeah, Robodom, I got a lot of sun when I was down. I don't know if you guys can see how dark I am compared to normal. I'm lighter up here anyways, but we configure and harden all our devices. We constantly patch and update all devices, so we have the newest version of whatever's running. That helps us get rid of the CVSS and the common vulnerability and exposures database type vulnerabilities that we might have. We run different firewalls. We got our network firewalls. We've got our host-based firewalls. So even if somebody accidentally opens up a port that they shouldn't, there's still an intrusion level of protection. And we've talked about that in other labs, and we have discussions on that and talks about how we harden systems. Then we train our users to not expose things. So I always talk about in the security space, there's 2 things that can be misconfigured. You can have misconfigured devices, but misconfigured users are really bad too, right? And people will argue in their studies on which one's worse of the 2. I'm not going to tell you which one I think is worse, but I think misconfigured devices, terrible. Misconfigured users, also terrible. So you got to configure your things properly, right? And then we secure the physical locations and servers, right? If we have a physical location, we protect it. If we don't, we protect the servers with identity and access management, which is what the defense in depth in the cloud is. In the defense in depth in cloud, we do not have physical security anymore. I don't even know where the data centers are. I know what regions they're in, but I do not know where they are physically around the world. So now my external perimeter becomes my identity and access management. Do I block all users from using? There was a big one that came around, and I try not to get into like these. I'm not going to be like, I've told you guys this, and for people that have been around with me for a while, I'm not going to get into like being one of these sensationalists, but I watched that thing go around about 2 weeks ago, maybe 3 weeks ago on, an S3 bucket will get you charges and then you'll be charged thousands of dollars. And I'm like, no, like you have multiple things you have to turn off for that to happen. The thing that they were talking about, an exposed S3 bucket, there are so many things you'd have to turn off for that to happen. And it was absolutely asinine to me. I'm like, so what we're arguing about, what we're arguing about here is almost like you're mad that if you go outside and just look up at the sun during an eclipse that it's going to burn your eyes out. And you go, well, what do you mean by that? And I'm like, there's so many safeguards before you went out there and did that like if you're going to go out and do that, I can't even talk to you about the merits of being not smart enough to not do that. If that makes sense, right? It's like you've already stepped under and over so many warning signs to get there that I don't even know what to tell you anymore. You would have to be like putting your hand on a hot stove in front of me, and I'm like, I don't even know what to tell you anymore. Like, anyways, all right. I'm not gonna get political about that kind of stuff because like people were really hammering that, and it was like this big old thing, and it's like, it's literally it was the same thing with if any of you guys remember Shell Shock. Shell Shock was a 100% exploitable if you exposed your bash shell to the world, anybody could exploit it and get into your system. If you expose the bash shell to the world, not behind an SSH connection, not behind a user connection of some type. Like, who the hell in all the world has ever done that? All right, I'm gonna stop. Defense in depth. We no longer have control of the perimeter. So we have to use identity as our edge, identity protection. And there's a lot of ways in the cloud that help you with this. I actually got hit with this when I was down in Mexico. I got a call from my college, and they're like, hey, you've got a lot of access. So somebody's been accessing your stuff from Mexico, and I teach remotely at my college, DeVry. And I was like, yeah, that's me. I'm down here. And they're like, oh, okay, good. We just wanted to make sure because like it shows that you're down in Mexico. And I'm like, well, one, I'm glad you guys found this on like the 5th day I was down here. And two, yes, I've been using my phone as a secondary multi-factor authentication every time, so I would think that I would actually have been, okay. They must have been panicked too hard. Well, Robodom, so what happens is in Azure, in their security portal, it tells you things about a user, and the very first response to anything that's questionable, like if you kind of set it to like a tight security, which we do not have at my college, but if you had a tight, or we don't have as tight as I would, the tight security is what the first response is, just force them to do a multi-factor authentication again. And that happened to me a few times, and that was fine. There's that. Is there a sequence to watch your videos? Ubad, there is no sequence to watch my videos. It's kind of all madness. But I will tell you, you're watching live. Anybody here is watching live if you're on here, or even if you're watching it later, this was a live video. I am going to be putting out, they're not going to be shorts. They're going to be actual videos, but they will be of our content. And, we will have each of those videos individually. I have a few that are persistent now. One is our networking primer for just networking talk. That's about 2.5 hours. I have our high performance compute primer. That's about 2 hours as well. And then I have another one out there. I forget what that one is, but more like that will be coming out, and those will be kind of ordered, Ubed. And also you guys can join the Discord and just talk with anybody, ask me down there and say, hey Scott, can you go over this again? I will absolutely do it. We typically have a meeting today on Saturdays down in our Discord. I'm not going to be able to make it today, but we meet weekly, and anybody can ask me anything that they want to go over in there. And it's very, I don't want to say it's one-on-one. We normally have about 3 to 20 people in there. It's our professional Linux users group meeting. But I would love to see that get up more than like, I've been telling people the whole time, part of the fun thing about using Discord for free is I've been trying to get us to where we break Discord. Like, what do they have us on as like a free limit? If we get 50 of us in a channel, is it gonna tell us we can't have any more? I'm kind of interested to see what that looks like. So, Startup Me said, howdy, do you have any kind of resource newsletter or updates with the most relevant vulnerability news or CVE details? I was trying to find something like that. No, Startup, a lot of times stuff like that is paid for. Like Tenable Security has one, and Qualys, those are the two that I know. But Startup, all of the CVE details are free to go and query. So I've actually often thought about that. Maybe I'll talk to the guys down in the Discord if one of the guys want to do a project where we just do like an API call for the last week of all the CVE stuff, and then we just kind of put down all the, maybe, I don't know, Windows, Apple, and Linux, vulnerabilities, and have them as like percentages of the total. That would be kind of cool, like build a little page and then just have it dump into our Discord. But no, Startup, I don't have anything like that. I've often thought that would be a fun thing to write, though. Like a little thing. Yeah, Yeah, startup. That might be something good. I'll drop that down in our little projects channel and see if anybody wants to do that. Bite Chip or Yo-Yo, been a while. Glad you're back home from the trip. Yeah, in fact, guys, I won't do it today, but maybe I'll do it tomorrow. I meant to like have all the pictures from the trip and be able to talk through and show you guys everything that we did. But there's that there. The Discord, hold on. Robodom, I might have to do it. Let me post it over there myself, Robodom. Hold on. And then if somebody on the YouTube side doesn't mind checking if the Discord comes through, I got to find out if I can make Robodom an admin over here. Hold on. Can I make add as a moderator? He is a managing moderator. All right. Robodom, if you refresh your page, you should have power over on the on the YouTube side of things. So, okay. So we got our identity and access, then we got our perimeter, and our perimeter here is more of like our network perimeter, so these are kind of together, but we don't have physical security anymore. Then the same things we were talking about earlier. Network, make sure you don't have ports open that shouldn't be. On the compute side, make sure that those devices are locked down in some way. Then the application, whatever the application is reading out of the data, should only be decrypting what it needs to. It should only have access to the data that it needs, pertinent to what it's doing. And then your data sitting here is just a lump, is just a tightly protected lump of encrypted data sitting there with its encrypted encryption key sitting next to it. And then we use envelope encryption to encrypt that. And I'm going to show envelope encryption here in a minute or two. Okay. All right. Now Robodom's got a little, yeah, Robodom's got a wrench next to his name on the YouTube side now. That's funny. So he's got too much power. Robodom, I think now that you can actually download videos if you need to. So if you need to do any of that stuff we had talked about, you can do that. All right. You got to protect the data at rest, encrypt it at rest. Again, I hate to hammer it, but this is important. AES 256 is the minimum standard for encryption in the cloud. And then protect data in transit, and that is HTTPS at layer 7 and TLS at layer 4. Both of those are using X509 certificates, right? And then you say, Scott, what the heck's an X509 certificate? You're throwing this new word at us, right? And it's X509. I'm going to show you guys this. I always try to make sure that you guys know about this. This is a free book. Free is like the best. But when it's really good and it's free, that's even better, right? So this is a free book on solving the bottom turtle. This was by one of our colleagues, is on this list here. One of the people that kind of stops by here. They've asked me not to say exactly who they are for other reasons. But if you come down here, and I always jump right here to page 41. 41 right here. And they start with this thing called A Brief Overview of X509. This whole book is very interesting and good. But that being said, this X509, if you struggle with what certificates are and certificate signing requests and what a certificate authority is, it gives you a really quick primer on that in case you haven't found a good one. And I'll tell you, this one's pretty good because the whole talk on Zero Trust, which is what this is actually about, is good. And it's free. Yeah, free is like the best price for a lot of things, especially when you're trying to get into the industry. And I can tell you that person comes around here quite a bit and is an expert. They are an expert. They go and they talk at SANS conventions, which is SANS is kind of one of the standards for security in the computing space. So SANS.org is real big on that. One of the things about SANS.org, though, is that it is a pricey set of training. SANS. Capital S, capital A, capital N, capital S. Hey, Twisted Seed, how's it going? I am just back from vacation. I did not prep all of my pictures. Maybe I'll show you guys the pictures later. But I just wanted to get on here and tell people, like, hey, I'm still alive, you know. Kind of, we blew up, had like 50,000 views on one of our videos from YouTube. And then I was telling people, like, then it slowly, like, dropped off. And I was watching, like, I was telling the wife, I'm like, I'm kind of watching my one little success on YouTube kind of, like, peter down into, like, nothing. But I tell you guys, like, I don't really care about being an influencer for damn sure. I don't care about being a content creator. I care about finding people that want to do this stuff professionally and then like digging in with them and figuring this stuff out, right? Like you guys can do this stuff. I can't do it for you. If I'm the first person on any of these channels that's ever told you this, there's no shortcuts. There's no easy way to do it. You just have to start doing it, right? And I need more water too. But yeah, if somebody, I mean, I would use the example of the Dread Pirate Roberts from The Princess Bride. He says, "Life is pain, princess, and if anybody tells you different, they're trying to sell you something." Windy Force, I wasn't planning on going to DEF CON because I've been doing so much with high performance compute and less directly on the security side. I mean, I do security every day, but I've been focusing on high performance compute engineering stuff. So I wasn't planning on going to DEF CON, but I could probably look it up. I am planning for sure to go to Scale next year because some of the guys go to Scale every year, and then we're going to have little shirts and stuff. That's going to be kind of cool. Yeah, you get a pile of gold service. Yeah. All right, so this is our defense in depth stuff. So let's go a little further. This comes directly from AWS. This is their shared responsibility model. It's to simplify it real quick for a second. Looks like this. There's the AWS responsible for security of the cloud, which is hardware, operation of managed services, and global infrastructure. So they are in charge of the security of the cloud, and you are in charge of data in the cloud. So data and configuration of things in the cloud is up to you. Okay. So I totally plan the hard work because you potentially get a pile. I still don't know what the plate is. All right. So we come back up here. AWS is responsible for giving you a secure computing platform, giving you storage that is durable and resilient. Durability of storage refers to if something happens to a bit in your data, it doesn't change because maybe it's got multiple other copies, maybe it's been hashed, and we know there's something wrong, so we throw it out and just use one of the other copies. Oh, hold on. You know, I guess I could pull up what I did in the thing from Discord. And then database, they'll give you secure and updated databases with, minimum amount of security or a minimum amount of vulnerabilities exposed. They will also update those on a schedule where you can select when that schedule is. And then networking, they're going to protect you across all of the TCP 0 to 65.535 and then UDP 0 to 65.535 in a way that corresponds with whatever RFC deals with that, right? That's the kind of things that happen on the cloud side of things. They're going to update their software. Their portal to connect in is going to be updated according to them. They're going to make sure that their hardware and global infrastructure and their networking is up. That's on them, not on you. Their regional design and routing and DNS and all those kind of things are on them. Availability zones being over 100 kilometers from each other, making sure they have their own power, space, and cooling. That's all on them. Edge locations, which tend to be partners of theirs, being connected back to their availability zones. That's a huge part of their infrastructure. And then those edge locations being up and being available. These are all the things that AWS is going to deal with. You are going to deal with loading your data. Loading your data will always be on you. If you choose not to encrypt and push your data up over, you can't even push things up into the cloud right now that aren't encrypted. But if you tried to, you definitely have some crap. Yeah, Robodom, I'm pretty sure these are all up on Discord. Yep, they should be. If not, I'll start kind of going through and auditing what is and isn't up there, and I'll start pushing more of these up there for sure. I think that would be good. Platforms, application. Remember I said your identity and access management, who you let into your systems is always going to be on you, right? It's like if you got a little hotel key and you gave it to somebody you didn't know. Well, how can you be mad that you gave access to that room that somebody else didn't secure it? That doesn't make any sense. You shouldn't give, like your house key. You shouldn't give your house key to anybody you don't trust, ever, right? The customer, if you deploy an operating system and that operating sits up for 5 years and never gets patched, that's on you, right? The network and firewall configuration of that are on you as well. Samuel, I think you can be very good at this. He said he really wants to be very good at this. You just got to start working on it. Start working through some of the different pieces. I have labs specifically around Linux and Ansible. Those are my main labs, but also some Kubernetes and some HashiCorp tooling, those kind of things. You're responsible for client-side data encryption. So if I want to encrypt data before I even push it up, I can do that. And then data integrity authentication, that's also on me, right? Keeping my certificates safe, those kind of things. Server-side encryption, this, by the way, is turned on by default. You have to turn that off. And then networking traffic protection. If you're not going to use the free certificate authority service that they give you inside of AWS, then how you can't blame them if you choose not to use the encryption that they give you for free. All the certificate stuff is free. It's actually a pretty good deal in a lot of ways. All right. So we talked about this. They're in charge of the cloud. You're in charge of data in the cloud. This is a very common AWS, but Azure and Google Cloud Platform are the same in this sense, right? All right, cloud service providers. Here's kind of a rundown. This is one that I found online. This is a reference to them. It's a VMware blog. And AWS to Azure to Google Cloud Platform. There are hundreds of things that go and show you how they compare, but these are the different ways that they name the things. I tell you guys, if you go take, like, I took the Certified Cloud Practitioner a few years back, and that test is almost exactly the AZ900 on the Azure side. I took that test too. The only difference is a few ways that they word things. Like the naming of their products are the things to know there. But the concepts, the core concepts of the cloud were exactly the same. In fact, the Azure side I studied for less than 4 hours to go past that. Because the AWS stuff was, it's a complete kind of understanding of these things. And then on the Azure side, I really just needed to know how the names were different. So, all right. So this is an interesting thing. So there's 4 things that are considered common, like, problems. There's connectivity, latency, capacity, and security. And I think all of those, if you understand them and understand those architectures that I showed you earlier, the AWS reference architectures, maybe if you're doing, I do mostly AWS stuff right now. Connectivity, latency, capacity, and security are all simpler if you build them in from the start. If you try to deal with them later and you're chasing after them all the time, I can see how that would be a major problem for you. So these are common things that are easier to do if you keep them updated. All right, so review. What is cloud computing? It is a well-defined standard by NIST in 800-145, right? That should be the standard. Yeah, NIST 800-145. We pulled that up, told you it's like 6 pages of them just patting themselves on the back, and then 2 pages of the actual standard. It talks about the cloud deployment models, the different ways that we can go public, private, hybrid, community, cloud, right? How we do that. It's got the cloud service models, which are infrastructure as a service, platform as a service, software as a service. I argue that there should also be like a function as a service, like in the future for kind of like this serverless type idea, but you know, they're going to update the standard one day. Who knows? Cloud security concerns, make sure that you're thinking about that life cycle of how you create and use data, because everything fits somewhere along this life cycle of where your data is. And this can define how you store data and how you move it around and how you share it and all these different things, right? There's all these considerations here, but this gives you a really good thing to kind of just stick in your head around, hey, this is how this works, and hey, this is how that works, right? That's the cloud data lifecycle. That's an ISC squared concept for your certified cloud practitioner. So if you tell me, hey, Scott, I want to go get my certified cloud security professional, certified cloud security professional, yeah, CCSP, then that's a big part of that. Nice. Yeah, I don't know Marcelo Dev SREs. Maybe they've got some interesting stuff. Startup. Yeah, I'll have to check them out. I haven't seen them before. I have a few DevOps people that I follow, but Dev SRE is nice. Yeah. You guys got to remember, too, like I tell you a lot, like I can code my way out of a wet paper bag, and I can code, but I am not a professional coder. So, like, I do all kinds of... I'm the guy that builds all the stability into the stuff under the hood. So, and I build the big data moving facilities and stuff, but I don't do a lot of, like, the... underlying code type stuff. In fact, I've never done that professionally. So that is interesting, though. I do have a lot of topics and stuff that I'm sure. And then common issues. You can, guys, all these different things that are out there, as long as you understand them, it will make it easier for you to work with them. All right, so questions. I always say just ask me down in the Discord. Let me go pop up the other presentation I was going to talk about. That was our intro to cloud. And then the other one is going to be compute and data security. So I'm going to pull this one up here in a second. But before I do so, we're going to take a quick little break. So I'm going to pull up my hourglass. And where's my little hourglass? And we're going to say, take a break, and then we'll come back. And let's see, quick break. And then more topics. And we'll say, we'll do like an 8-minute break real quick. All right. Oh, somebody wants to check on Ranger? Hold on. Let me stop this. You want me to put Ranger in the background while I go? Here is... That's our Ranger check. How's Ranger doing? All right, I'll tell you what. Quick break and then Ranger treat. That sound good? Quick break and Ranger treat? All right. That's what we'll do. I'll be right back, guys. Give me a few minutes. Robodom's in charge. And then I got asked about my career track. I will talk a little bit about that when I get back, yes. There's Ranger munching on his treat. I'll be right back, guys. All right. Robodom said, Ranger must have been so happy to see you and the wife again. Yeah, Ranger was pretty happy, I think. I think Ranger was pretty happy. And now he's sitting there munching on his little treat. Same old Ranger. Yep. All right, somebody asked about my career background, so I'll pull that up while we're kind of hanging out here. I have it in... Let me see if I have it. Hold on. I gotta look at something here. Pull this up here. I think I have it in the Prolog side of things, but I'm not sure exactly where. All right. Well, I'm back, and we'll wait for Ranger, and wait for the break to end. But I'll pull this up while we're kind of sitting here. I think I have it down here, and I think it's het resume short. Hold on. Het resume short. Yeah, here we go. Pull that up here. Give me 1 second. Get this other one out of the way. All right. So, as you guys can kind of see, it's still kind of generic, right? I have it generic, so you can't really see my info. But that's kind of like a resume kind of function that I like to use, or a resume template that I like to use. This is my short one that's only 1 page. So I have a template that I use that's shorter. Hold on. I'm just going over this a little bit here while we're still on break. And Ranger, there's Ranger Cam, so you guys are good. And we'll get back to actually starting the presentation in a second here, but I got asked over on the YouTube side, could I give a little background of like my career track? And I can do that. So I started off in, this one only goes back, by the way, to 2009, so this one doesn't go back all the way. But I got out of high school in 99, I graduated high school, went right in the Army, right? Because I thought I was too smart for everybody. So I went into the infantry, because that's not very smart. And while I was in the Army, I got my CCNA. I went to college and got my CCNA. And then I deployed to Iraq in 2003, so I was there at the beginning of the Iraqi war. So if you guys ever want to hear what happened or tactics about any of that kind of stuff, I can tell you a fair amount of that, because even though I was just a dumb little infantry guy, I kind of knew what was going on. That being said, got out, started working at a Peoria school district, Peoria Unified School District out here in Phoenix. And fun fact, that's where I met my wife. She was help desk at the time. And then I started working on just moving computers around for school district. That's what a local area network technician does. They move computers around. In about 2004, from that, I moved over to, I did all the firewalls for the school district, and I did all of the wireless. So I built all the wireless infrastructure. I did all the site surveys. I taught myself how to do site surveys because there wasn't a lot of documentation in the early 2000s really how to do them. So I went out and I mapped all the schools, and then I walked them with an RF, like I had like my little laptop set up with port swigger, not port swigger, air snort. And I had air snort, and I knew exactly how strong my radio signals were with my Cisco access points and stuff. Yeah, CCNA was extremely popular back then. And I tell you guys, this is not a joke. Like, when I tell people I had my CCNA, I 100% am not joking about this. And you might not believe me, but I'm going to tell you it was true. I was running around as a little infantry guy with my rifle. I could program the hell out of a switch and a router. I could not tell you what a server was. I had my CCNA. I could not tell you what a server did. If you were like, hey, what's a server? I'd be like, it's something on the network that I give ports to and route IP addresses to. That was it. That's what I knew about it. But I knew my Cisco side of it really well, which actually was really good. And then I got out, and I eventually got into Linux in early 2000s, probably about 2004, because I got promoted to a LAN 2 at the school district. And the very first project I ever used Linux for was, it was like a Red Hat 4 server that I built. We had a server sitting there, and I had set the firewall to lock down all traffic going out. Because most firewalls, especially the early PIX firewalls, which is the Packet Internetworking Exchange firewalls, they're the ones that became the ASA firewalls. Those ones, they had a trusted internal and then an untrusted external, and you could set it between 0 and 100. And what we did was we inverted it, so we made nothing trusted anymore. And the only way you could talk out was to go through this lower networking scheme of the school district. So at all the schools, well, we did that because we were moving off of WebSense to this tool called Computer Associates. And the Computer Associates proxy only allowed us to do port 80 and port 8080. So when we did that change and how things couldn't communicate out anymore, I broke this. Well, I didn't break the tool that they decided to. Broke the library software. So the library software was like a $25 million library software that we had that had to talk out on, let's just say, port 5000. Let's just say. It had to talk out on some port. I don't remember what it was, but let's just say it was 5,000. And to talk out, it was bouncing off the firewall. Well, we couldn't point it down to the computer associates to get out because it couldn't use those ports. The computer associates would only do like 80, 80, 80, 443, and 8443 or something like that, which are all your normal communications. Well, so what I did was I went and got a little Linux box. This was my first professional foray. This is the first thing I ever did with Linux. And I built like this little Red Hat 4 server or whatever, and I put a SOX proxy on it. And that SOX proxy said, if anybody's talking on this port from these machines in this range, across all the schools, they can come and talk to me. They'll all come and talk to me, and I'll send them out to the world. So I had a $20 million computer associates project that was coming in, and like a $25 million library program, and they were breaking because of something that some person, some architect well before me, hadn't thought of. So I used one free little Linux box on top of a thing to deconflict and kind of let those ships pass in the night. And that was like my start of doing Linux, was this in my mind, wildly successful deployment that deconflicted a thing that wasn't even my problem or my designs, but I got it all working very quickly. And that to me was like, hey, this is a pretty powerful little tool. This is a very popular, or very, not even popular, but very powerful way to do systems engineering. Now, again, in that case, it was like a shunt holding the door open, and that's not the way we want to design things. But once I started realizing, like, hey, this can really be designed into a lot of things, it started to be like super useful for me. Okay, so anyway, so that was kind of I got asked over on the YouTube side, could I give a little background about me? Since then, I've been over, I ran my own business for quite a few years until early 2008. Then I went to start working for Lockheed Martin, and I worked for Lockheed Martin for about 4 years. Well, it's just says government engineer or government whatever, but I was at Lockheed Martin. Then I went over and I worked for a company called, this is CGI, right? And then I used to teach when I first started teaching in November of 2008, that was at ITT Tech. ITT Tech doesn't exist anymore. They did a lot of stuff with VA loans, and they were at like a 95% federal funding rate, and it really didn't go well for them. But I feel like I gave my students really good engineering. I still have a pretty good rapport with a lot of my old college students, and they seem to tend to think that I taught them some good stuff. Then I went over and I worked for a company called Caris, which is a cancer research company. They still exist out here in Phoenix, but I built a lot of stuff for them. And then I went over from there. I worked for a tiny little bit of time. I don't even have it on here, for Silicon Valley Bank, but the drive was killing me. It was like an hour and a half each way. It was just killing me down in Tempe. And it should only be a 40-minute drive, but traffic made it about an hour and 40 minutes. I just couldn't do it anymore. So I went over, and then in the last few years, I've either been at AAA as the platform engineering lead for all of like Windows and Linux, over about 5,000 systems total, or I've been at like Best Western as their Ansible architect, or I've been at Redline. Redline is the company that contracts me out for high-performance compute stuff. So in the last like 5 years, I've been at one of maybe 6. What are we in, 2024? So in like the last 5 years, I've been at one of those roles. And the reason you say, well, Scott, why can't you just tell us them in order? Well, it's because it went AAA, Best Western, layoff for COVID, Redline, back to back to AAA, and then now I'm at Redline again. So like I've kind of jumped between these companies that liked me, but had different reasons for working for them at different times. AAA, I was also the red team lead, so I was the technical lead for all of the red team activities that we did. So that was, we ran the web application firewall, we ran all of our penetration testing, we ran all of our DAST and SAST. So SAST is static application security testing, and then dynamic application security. Actually, no, I take that back. We didn't run DAST and SAST. Another team did, but we coordinated with them on new applications coming out, because after they ran them, I was still part of the process with that. But then once they ran it and it became live, then it became us to test it and run our. We had both penetration tests and vulnerability scans that we did, and I wrote some of that stuff myself. And worked with our different red team guys to build some of the tools that we used and stuff to automate, just kind of like just checking doors, checking windows, making sure things shouldn't be exposed that aren't. Not to get into numbers, but looking at your career and the money amount for software developers these days would you take the same track in startup? I don't know. Like I know I could code if I wanted to. I just never loved it, if that kind of makes sense. I never like really loved just sitting down and coding, but I do a lot of like configuration stuff that also takes a lot of brain power. I see some of the numbers on like levels, like some of my buddies do like levels and stuff, and I'll see things like guys are making like 700K or something, like, God, that's pretty high up there. But then I find out that that's like this one extreme outlier of some engineer, and then I see numbers that like, well, but the average software engineer at Amazon only makes 90K or whatever, and I'm like, that's not anywhere near approaching me. So you know what I'm saying? Like it's like I don't mind getting into numbers, but I mean it's like I'm about as high as I can go on the engineering side and what I do, unless I want to go to management. And I tell you guys this all the time, you know, talking about careers and stuff. They've been trying to make me a manager for 20 years. In fact, one of my things about college teaching is I get all the wiping of people's noses and wiping of boo-boos that I need as a college professor. I don't need to do that in my professional life. So I tell you guys, in my professional life, I like to build things, I like to document them, and I like to kick them out so that people can go run them, and then I'll fix them. I don't like to baby people. I don't like to wipe their noses, wipe their boo-boos and kiss them and stuff. I don't want to do that professionally, if that makes sense. So that's why I'm not a manager. Also, I just like, there's something nice about like if you get into Linux systems engineering where like you can show somebody it literally hundreds of times and they will still just see you going like this. They will still, at the end of the day, they will still just see you going like this. Magic, right? There's my little Linux penguin. That's what they'll see. No matter how many times you explain it to them or show it to them, they will still just think what you do is magic. And I just like, oh, okay. I guess I'll just keep doing it for money then. As long as they're going to keep paying me. Yeah, Robodom, you didn't see that coming, did you? You didn't see the penguin being under there. All right, anyway, so that's kind of my career. I'm still teaching at DeVry. You guys know that. These are some of the classes I've taught. I could actually add to this, but I just don't really care to right now. But yeah, this is kind of what I do there. I ensure a high degree of technical acumen is trained into our engineers. I adhere to published curriculum standards and ensure students learn the hard and soft skills of the engineering profession. That's what I think I need to do. That's my job. I encourage my students to be the best versions of themselves and hold them to a higher standard than they hold themselves to. I also think that that's an important thing to do as an instructor. People will hold themselves to a certain standard, but it's higher. It should be higher, right? And I've often talked about this, like when we talk down the Discord and stuff. Like, who failed you? If I don't give you the same treatment as a student as I gave all the other students, or if I just pass you along without actually teaching you something, I just let you be like a shitbag the whole class and go on. Who am I cheating? You or myself? I'm cheating you, right? You're paying a lot of money to get told the truth, hopefully. And I've told students over the years, I'm like, wait a minute, so you hate this? You don't want to do this at all? Maybe the best thing that you just spent your money on was figuring you didn't want to do this, right? And then this is also me. This was me at AAA. So this is my AAA stuff here. I need to put my Redline stuff on here. And then also at the end of this year, I'll be at 16 years of teaching. Because I started in right at the end of '08 teaching college. So. All right. I agree, Robodom. I agree. And I've told you guys this before. I don't think you need school and I don't think you need certs. But they do give you a positive differentiator for other things. So, yeah, Baba, hopefully that stuff's useful to you. Just kind of talking about where I've been. What I currently do, I work in the high-performance compute space for Redline, and I get contracted out to different government jobs. And almost exclusively, what people want me for is Ansible automation, because that's what I do a lot, and configuration of like building environments out. I tell you guys, at the risk of being a Chad about this, I am very, very good at making 100 servers exactly the same. And you might say, well, I could do that too. I hear that all the time, right? And I show engineers how to do it all the time. But I'm still the one that when I push the button, all 100 servers are the same. And a lot of other people, for some reason, when they push the button, it looks like a squiggly little line of 99 different servers and one broken one, right? So I try to show people these methodologies and stuff, and there's a lot in like the Ansible part of it. But like there's answerable. It's funny. The word answerable is actually where Ansible comes from, but the word Ansible is different. But that is where it comes from. What do you mean by 100? So if you had 100 pieces of physical equipment in a rack, and I had my BMC connection to all of them, or my IPMI connection to all of them, I will deploy 100 of the exact same server via XCAT configurations and kickstarts and Ansible configurations. And then you say, well, these 9 are different, but I need them to be the same on all these other places, but I need this to be a little different. I can do all that too. So like 100 servers with, Red Hat 7.9 updated to this version of the kernel, this version of OFED, this version of GPFS, and then rebuild the subsystem of GPFS, and then have everything configured properly. Those are the kind of things that I'm good at, and they bring me in for a lot of times. I can also maintain servers and stuff like that too, and maintain documentation and stuff. That's another thing I think I've always been good at, is kind of like my documentation, keeping track of things and that kind of stuff. So like what I did and making my work repeatable for other people. So that's kind of my thoughts. Yeah. And again, I tell you, like, at the risk of sounding like a super chat or something, no, that's what I'm good at. Like, that's what I kind of have always been good at. So that's funny. All right. So we're going to talk a little bit about data and compute and data security. This is specific to the cloud and almost more specific to AWS, but this has also got a lot of generic stuff in it. And I probably need to update this because I did this back in November of 2022 to Prolog, to our professional Linux users group, which, by the way, I haven't posted in a while, but we've got a Discord. I'll do it, Robodom, just because I'm going to share it. There's our Discord, and then I'll share it over on the YouTube side as well. Because I just want people to know that, like, hey, there's a place out there where engineers are hanging out. Engineers, architects, we've got security guys down in there. We've got people that exclusively use Apple and people that care more about software security, and some people care more about freedom of software than others, and there's all kinds of stuff down there. So there's that. Robodom, I'm not automating your job. I just know. Wait, actually, I take it back. Robodom, will you take that link and post it in YouTube and see if it works for you now? Even though it's going to be just a double post, I just want to see if it posts on YouTube for you. Now that I made you a little robo mod. I'm curious if it'll work for you. All right, we'll get into this. So, here's our talk of security. We're gonna start with, yep, it works. Okay, good. Protecting data security. There's this CIA model. It's been around forever. It's confidentiality, integrity, and availability. But I'm gonna tell you it the way I think of it, because there's pieces to it that I hear get mentioned, but people don't really talk about it much. Then defense in depth, which also goes back to a talk we just had, where defense in depth of the cloud and how that's different. How we access the cloud, I mentioned this a little bit earlier. Everything's always an API, even if you're on the console, even if you're on a web portal. And then data security, data at rest, data in motion, data in use. So data in use has kind of been added. It was always in rest and in motion. And then we'll talk about compute security. If I'm going to deploy something that's using CPU cycles in the cloud, how do I protect that thing? Then encryption techniques. What does it mean to be symmetric encryption or asymmetric encryption? Knowing this is kind of the crux of everything. And then how about the SSL and TLS certs? What are they? What is PKI? What does it mean to have a PKI environment? And then we'll troubleshoot some cloud, common issues, build security into your deployment. I was saying earlier, if you build security in to start, everything else gets easier as you go. All right? So this will be kind of our stuff that we talk about here. All right. Everybody with me? I think everybody's with me. All right. Discord's there for you guys to go play with and talk and share memes and do whatever. All right. So let's talk about protecting data security. There is a private key infrastructure. In fact, yep, that's right, Robodom. Confidentiality, integrity, and availability. Confidentiality is who can see the data, right? When data is leaked, we call that, a breach of confidentiality. It is a security incident when data is leaked. But I want you to think about confidentiality data for a second. If you've never, let's say you work for a small company, or maybe you work for yourself, or you're just sitting around thinking about, hey, my own data at home. If you've never classified your data, so you've never set, hey, this is generally accessible, anybody can see this. This is personally identifiable information, so maybe it needs to be like secret or something, whatever classification levels you have. But if you don't have classification levels, can you then provide different levels of security for your data? And I would say no. One of the things you have to think about with confidentiality, it's not just I've got my arms around all this data and all this data is secured. No, because all that data has to be accessed differently, and when we assign classification levels to it, it is now protected differently. What do I mean by that? What I mean by that is, if I only had $100 to spend to secure all this data, I might say, you know what? All this data over here is pictures of cats and flowers on my fucking websites. I don't care about putting that behind like a PCI DSS protected environment. But this data over here, this credit card data and all of my users and my customer database with all their stuff, that's going to sit over here. And it's going to be like real secure. And I'm going to spend like 95 of my $100 that I have here. And you know what? If you compromise my webpage, I'm not going to be happy about it, but I'm going to have a lot more into protecting this resource over here. But you defacing my website, it's not great, but it's not what causes my business to go under because you got a hold of all my tasty data, right? And confidentiality at the end of the day deals with that. But I just want to point out, you need to classify your data so you know what you need to protect. Because if not, you're just protecting a big glob of data, and it's all data. And there's no rhyme or reason or hierarchy to it, right? So that's an important thing to think about. Integrity is two things. It's who can change the data. So this is our protection against ransomware in some ways, but who can change the data? And what's read-only and what's this and this and this. Integrity of data is who can change it, but it's also this other concept called durability. This is what I was talking earlier about durability in the cloud. You'll hear that S3 has a durability of 11 nines. That's 99.9999 bunch of nines percentage, right? Of durability of your data. Well, what if, so let me think about this here. If your data was sitting on tapes, they're on a LTO4 tape, and after 10 years of sitting there, they've oxidized on the tape because they're sitting in a slightly more humid environment than they should have been. They're not being held in a humid environment. You went and threw them in a water closet where, like, sometimes they're in their little containers, but sometimes the mop from the janitor gets put on top of them, and you go to read that data 10 years later. Right. You're just about to decommission the old LTO4 tape reader and get rid of it. So you go to read all your tapes and the thing starts to spin and just rips the tape in half, and now you don't have that data. Is that still an integrity problem of your data? Yeah, it absolutely is. What if you use an old file system that doesn't have bit error replication or the ability to fix bits that have changed? You don't have hashes on your data to make sure it hasn't changed since you put it down or any of those kind of things. That's all integrity, right? But that's not necessarily somebody illegally changing your data or overly permissive data being out there that can be changed. That's entropy, the passage of time, right? This thing all things devours, birds, bees, trees, flowers, right? Does anybody remember that from The Hobbit, the original Tolkien? That was the time, right? Time. Hopefully I didn't just spoil a book. Nobody needs to be saying a spoiler alert or anything on a book that's over, I don't think it's quite 100 years old now, but it's pretty close. Right? And the movie's been out for 20-something years, too. I take it back. The Hobbit's only been out, like, I think 16 years or something. Anyways, I don't know. Point is, integrity. What's changed? Availability, then. Is the system available for use at all the times it should be? This deals with uptime of your systems, but uptime, we almost always measure uptime in number of nines. So let's go here. If you've never seen this, when they talk about like high availability or uptime, they almost always use one of these, right? Robodom, I read The Hobbit 13 times as a kid. I also read through The Lord of the Rings 9 times as a kid. Really liked those books. All right. Most government systems I've worked on, we will do this right here twice. So like downstream of satellites and some of these other like big data systems, when we absolutely 100% need them to be up. Because, by the way, does anybody here ever know or ever work with satellites? If a satellite goes to pass over to its downstream station and it can't downstream the data and has to go around the Earth again and come back, do you know how much of the data from the day before is retained in that satellite? Does anybody know here? Zero. So, knowing that, you have to catch the data. You cannot not catch the data. I know that's a double negative, doesn't matter. You cannot not catch the data. You have to do it. So what we would typically do is build a 99.8% reliability system and then put two of them next to each other. There's actually a really great... Baba, oh, yeah, sorry, I already told you. But I can tell you guys something funny about this. This was actually... So there's a show that my wife liked, and I think I watched up to season 4. I never really got super far in it. But it was called Arrow. Does anybody remember Arrow? It was a DC show. When I say DC, it's the DC Comics, right? And I thought this was an absolute masterpiece of one thing. It was at the end of season 1, and it was something that I absolutely called. I looked over at my wife and I said, I know exactly what's going to happen here. And she had already seen season 1, so she already knew too. Oh, is it Green Arrow? Is that what it's called? I forget, but it's the guy that's basically Robin Hood or whatever. Yeah, Oliver Queen. Okay, so what he does is at the end of the first episode, they go and they stop this little seismic. The end of the first season, rather. By the way, spoiler. Just turn off your sound if you don't want to hear this. Don't look for a second. He goes and he stops this seismic thing, and then over on the other side, they're stopping the bad guy. And he goes, yeah, this was just Arrow. Yeah, and he goes, oh, do you know what the one thing was that I learned in business? Always have a backup. And then it moves over and it shows this other one like across the city, and it just goes off anyways, even though he stopped the one. And I was like, that is the absolute best representation of this concept that I've ever seen. Was they did it right at the end of that season, and that's like the only thing I remember from that show. But it's like, this is what we would do. We would have a highly available system, but like, so this is a thing I tell you guys too. To push from, if I went from a 99.8 to and I wanted to go up here and then over to here, it is an order of magnitude higher cost. So what do I mean by that? If I was at a 99.9% and I wanted to add one more 9 of availability here, it is an order of magnitude cost difference. So what I mean by that is, if this was a $10 million project, this would be a $100 million project. And this would be a $1 billion project. And then this would be a $10 billion project. So it's cost effective here. If this was, let's say this one then was 10 million and this was the 100 million, it would be more effective to go 10 million twice and then just have those systems always up than one system that's sitting down here. Does that make sense? And that's where it goes for. Or that's a way. Now, it's not a hard fast rule that it's a one order of magnitude higher. I'm just going to tell you that's about what I've seen. So basically multiply by 10, right? An order of magnitude. Or divide by 10, either way. All right. Anyways, there's Ranger down there. He's laying around. So that's the CIA triad. I kind of hammered that a little bit, but that's important for you guys to know. All right. Oh, also, it's 9:44. I don't have much more time here because I do need to get off of here in a little bit to work with my college students. I got to catch up all my college students because I was down in Cancun for a week. But let's get as far through this as we can. If you guys have questions about this, join the Discord, talk about them down there. Some of the different engineers have seen this stuff, or they can point you at other resources that are valuable. This is the same thing we talked about earlier. This is, in fact, my same slide from my other presentation. So we kind of covered this already, but defense in depth is this idea that in the cloud, we don't have physical security. I can't physically stop you from going into an AWS data center. I don't have that power. But identity and access is where I block you. Do you have access to do the things that you want to? Love from India. Really enjoy the talks. Yeah. Hopefully this stuff's useful to you. You know, this is this is a little more chill stream for me, but we're just going through cloud security and that kind of stuff. So nice. Yeah, Rust. Okay. I have never done anything in Rust. I've done a fair amount in Go over the years, but never touched Rust. Also, I tell you guys, I'm not a professional coder. I just play one sometimes. Anyway, so defense in depth, we talked about that. Let's talk about accessing the cloud. How do you get into the cloud, right? Like you're like, oh, Scott, you want to do some cloud stuff, but everything is an API call. So you have console access, right? That's something that you've probably done in labs and stuff. So I hop over here, and I go over here, and I go AWS, simple to serious, right? And then I come here and I go to maybe my Scott. That's not my user on here. And then down here, oh, can I get in there? I think it's, oh no, it's not that. Oh shoot, I don't know. Oh, here it is, okay. But this is all API calls happening right here. Everything I could do in here, if I come, oh, excuse me. If I come in here to launch an instance of an EC2 instance here, this would be an API call at the end of the day, right? It's all API calls under the hood. And then I've got different snapshots of servers, and I have things that have been built with Packer coming up. Yeah, thank you, Robodon. I appreciate that. So I can access things this way, but this isn't really the way that we build things, right? We're still going to use an API here, but we're probably going to be doing API calls from like a command line tool or like a software development kit. So one of the things I show you guys in one of our other talks, I'll just pull it up here real quick, is if I were back here on this guy, where are we at here? Code examples, Linux admin stuff. In here, we had this AWS deploy that we used to use here. And then if we CD down into roles and then go to AWS deploy and then tasks, we'll look at our main.yaml in here. And in here, what we were doing is we were talking to Vault in my home lab environment, hitting Vault with a password and a username, and then we were getting this little token, and we were taking that token that it was giving us, and that happened here, and then we were feeding that token back in, and we were getting AWS credentials. Those AWS credentials only existed for 10-minute time, and then we would go run those keys through this Terraform over here. Again, this isn't really what we're doing right now, but here's our Terraform that would then go and it would deploy 10 instances of this. And when it was all done deploying this, it would then send an alert out to our Discord, and people could go grab these AWS tools. But this is all infrastructure as a code inside of Terraform, right? This is a way to access the cloud, but not through a console. Because again, a console's okay. This console access is okay. It's right here. It's me connecting in and going, launch instance, launch instance, launch instance, launch instance. That's okay. And we had already baked up the instances as AMIs, Amazon Machine Images, in the cloud through our tool called Packer, right? But hold on. With our command line stuff, here, I could bake all this other stuff in. This was all user data, and I would give it a username and a password and allow you guys to log in via username and password. On the back end, I would connect it to Amazon EFS and go and mount a back-end file system called Labs. And then when you logged in, all of our labs were sitting back there. I'm going to probably resurrect this a little bit, and then I'll probably change it to be, maybe I'll just change it to you can connect with a key, and then we'll just have the key rotate and be inside of the Discord. That might be a good way to do it, because then everybody could just have a key to get access. And then the output would be a bunch of instance information, and then this would report back. What? Oh, up to. I was like, where am I? At the very end of this, it would write this back out to our little Ansible Discord webhook, and then we would report out to Discord, and then what this used to look like back in the day in our Discord. I should probably resurrect this project, because I used to like to do this, and then on stream, we would just be able to all hop in here together, and it would right into Sandbox. Let's go look at our sandbox. Hold on, I gotta change this music. I don't dislike this music, it's just a bit too... Oh, here's acoustic guitar. Here's our sandbox. And then we go up... fucking sandbox. I have to go up quite a bit. Let's see if I can go page up for a little bit here. I don't think I've deployed this one for a year or two. But this is what it used to look like. Oh, we had a bunch of stuff when people were doing Code Wars. We got a little bot that Fisherman Guybro wrote, and the bot does a lot of cool stuff. This was us doing Grafana. Sandbox has open AP or has open webhooks for people to write into. We had all this stuff. People were playing quiz games in here for a bit, so we need to go up just a little bit to get past the quizzes. They were all Pokemon quizzes, by the way. That bot still works, by the way. Just nobody's been using it lately. All right, keep going up, get past this, and we'll get to one of the outputs from this. This is what it used to look like. I would say the Prolog lab is live for the next 4 hours, deployed on 22/11/30 at whatever time, so 2022. Here was the remote user and the password, so I would set those in the Terraform. And then here were all the servers, and I say instructions: find the lab to complete whatever lab I had built or whatever, and then SSH to whatever with the server name. In this case, there's the username, and then learn something. No, Robodom, this is how I used to deploy it in the cloud. So you guys used to go to my AWS resources back then. This is AWS. No. My home lab you guys can access through Guacamole. Robodom, I know you have access. Some of the other guys have access, but there's like a Guacamole connection, which is just in the browser. You guys can connect in. And then we have the Bastion when the Bastion's up as well. So for people that haven't been around for that, I have a fair amount of security background in deploying Bastions for the government. And I build them also on the outside world. And I show you guys how to build them. They're not super complex. They're just another tool to work on building your stuff. Okay. All right. I only have a little bit of time because I got to go yell at my college students in a little bit. And jokingly, do you guys know why I yell at my college students? Because they're not going to yell at themselves. All right. I'm kidding. But anyways, so this is how we access the cloud. Console access SDKs, right? And then command line tools. The command line tools you just saw me using was I used Ansible to connect over to Vault. Vault would then give me my credentials. My credentials would then be fed into Terraform, and then Terraform would go and deploy my resources for me. And then it would come back. Yeah. Oh, my students never miss me. I assure you that. Then the tool after everything got deployed, Terraform would report back. Ansible would then have control again, and it would launch it up to the Discord webhook. So that was my tooling. And I have a talk on this. This all happened. I did it was actually a Kubernetes talk I did on Vault, and I showed all that stuff, and that's all up in the Discord as well for people that want that. And just ask me if you can't find it, and I'll repost it. But I have a whole talk on how I did all that. And then I have labs that kind of show you how to do some of that stuff in Killer Coda. By the way, Killer Coda, I think that's the best site on the web. Robodom, will you do labs for everybody on both sides? On Sundays, so I'll be on tomorrow, we just do labs on Sundays. Lab Sundays, that's what they are. So in about 24 hours from now, I will be on this channel and on the YouTube side just doing labs. That's all we're going to do. I mean, I'll talk and stuff, but I mean, I'll be adding color commentary to it, but it's all labs. And then sometimes people will say like, hey, can I do more with this? That's where we have the book. The book is our big Prolog Big Book of Labs, and that's actually funny enough with all the stuff going on YouTube with people watching. People have been buying the book a lot, which I think is kind of cool. And again, the goal of it all is you could ask any questions you want in the Discord. The goal of this is to take you from being a beginner or a hobbyist, right? We're all hobbyists playing around, and get us to doing it professionally. Because honestly, you can make a lot of money. I think it's just book, Robodom. But I need to fix the book because, no, it's actually updated. All this stuff's updated on the book. But there's the book. Okay. And I think he's going to drop it, hopefully, on the YouTube side, too. This is the shared responsibility model. So customer data is always your responsibility. And we looked at this a little while ago, so I won't go over this again. But you'll notice that there's some overlap between my two presentations that we're doing today. But we talked about this a little bit. The big four: compute, storage, database, networking. Those things are big. All right. Then we come down here, data security. So let's talk a little bit about data security. How do we protect the data? When do we protect the data? Well, data are needing to be protected all the time. There's no time when data should be left in an unencrypted state, tasty data for people to get at. You can think of this as like if you've ever been to the beach, should you leave a hot dog just sitting out there at the beach and walk even 3 feet away from that thing? And the answer to that, to any of you that have ever been near a seagull, is absolutely not. Unless you want to get in a fist fight with a seagull, that seagull's coming at you, right? That thing's going to come at you hard. So when do we protect our data? All the time. And by the way, it's not seagulls out in the internet, but it is persistent attacks, right? People are constantly banging on the front door. If we come over here, and I just did a, actually, let's not watch it down here. Let's watch it up here, right? We'll close out of that. We don't need that right now. I have one of these. If I can find one of my non-busted ones. Let's find this one. Hopefully, yeah. So look, in the last 6 hours, these are all the people that have tried to connect to my server out in the world. People trying to come in from root, people trying to come in from different users. So they're mostly bots. Like I don't use their IP address. Here's all their IP addresses, the people they're trying to connect in. I don't use their IP addresses for any retaliation because most all of them are just moms and grandmas in Kansas City that got compromised and are part of a bot network now. They're not really the problem. They're just part of the problem, right? But they're trying to come as Oracle, admin, invalid user Tom. Maybe I had somebody named Tom in my server. They try root a lot, a whole lot of root. They get locked out forever after a certain amount of time. That's a fail to ban function. And then I keep track of how many have been locked out forever, right? This is all part of my security. Root can never log in my systems. Root can never log in directly in any systems I work on. You always have to come in as a user and then sudo up to root. There's a certain amount of protection there. Main reason you don't want root to ever be able to log into a server is because root on modern Linux systems does not ever lock out. So that's important. Threats are very real. In fact, when we used to do that thing earlier where I was standing up EC2 instances, those servers would start getting scanned within 5 minutes. When they would come up, and I would have port 22 open, of course, they would be found and people would be trying to log into them like this within 5 minutes. So that's how long an IP address needs to be up. Under 5 minutes typically, before something has, in its sweeps, found a response of an open SSH and tried to connect to it. It's that quick. That's shorter than patching would occur. What does that mean? That means if you're going to have something exposed when it comes up, you need to have it already patched. Or you need to have something patched, bring it up with at least an Etsy no login on it. Jeez, please, at least that. And then remove your Etsy no login when your patching is complete or whatever. Hey, thanks for the follow, Dr. Stud. Hopefully this stuff's useful to you. All right. So anyways, that's enough of that stuff for now. We get into all that in the different days. So people on the YouTube side, people on the Twitch side have seen a lot of this. But if you're on the YouTube side and that's interesting, best way to give me any kind of feedback is on Discord, because you can say, hey, Scott, I want to see that again. Or, hey, can you go more in depth with some of that? A lot of this stuff is just me kind of glossing over, and then we can go deep if we need to on a lot of this stuff. All right. So data at rest, data in use, data in motion. I'm going to let you guys read that if you hadn't already, because we're going to talk about a lot of it. Data at rest is almost always some type of envelope encryption. And then what happens with an envelope encryption, and we'll get into it here in a second, is we will encrypt the data with a data key. Then we will encrypt the data key and set it right next to it, and then put all the data out on a shelf somewhere, like in an S3 bucket or something. Then the key that encrypted the data key is called the customer master key, or sometimes people call it master keys. Or some people call it the customer key. Now there's all kinds of things. And then that key is stored off in some other place, like key management system of some time. You access that, it goes and decrypts the data key for you, gives you the decrypted data key. Then you take the decrypted data key and decrypt the data. That's what an envelope encryption is. An envelope encryption is once I take some data that's just tasty data and I lock it up and go put it somewhere, now I've got this key. What the hell do I do with this key? I can't put it next to data and I can't keep it here because I need other people to use it. What I can do is I can encrypt that key and put it right next to the data. So now there's the key encrypted and the data encrypted. And then over here, I give somebody access to the key that can decrypt the key. They decrypt the key, get the key as an open. They can decrypt the data, get the data open, pull the data out. That's how it works. That's how encryption key. Oh, I got pictures of it. All right, here it is right here. Envelope encryption is the practice of encrypting plain text data with a data key, then encrypting the data key with another key under another key, and then you can encrypt the data encryption key under another encryption key and encrypt this. I've seen envelope encryption 15 deep before, never practically, only in like a lab environment. And I need to find it. Hold on, let me try to find. Let me see if I can find this. Hold on. There's actually a game for kids that deals with key encryption. And somebody put a pretty cool little, there's like a little card game that teaches kids how to do coding or how to do key. Wait, wasn't it synchronous, asynchronous, and hashing? Those are coming up. I'm going to talk about those here in a little bit. I think I talk about those a little bit. I don't know where those are. Did I miss that? Oh, here's the asynchronous. Okay. Yeah, Mr. Extremely. Wasn't it synchronous, asynchronous, and hashing? I feel like I missed something. Yeah, symmetric and asymmetric for sure. No, I was thinking of this game. There's a game somebody made that's like a card game, but it teaches kids encryption. It's not this. There's a card game for it that teaches kids. All right, anyways, guys, there's a lot of encryption resources out there. And I don't have any of them on here, so... but envelope encryption is a very important concept. Yeah, you're fine, Mr. Extremely. Don't worry about it. Data in use in masking. So maybe a production database, you have your data, but then if you're going to feed that data out to other databases, why leave the data in a readable format if it doesn't need to be read over there? Why do your developers need a full copy of the SS? So you'll hear about this in the news where like somebody had their laptop stolen and it had all the social security numbers or something on it because somebody was working with something. Well, why the hell would they need that? Hey, how's it going, Hack the Planet? Hopefully, yeah, good afternoon. I'm still in the morning over here in Phoenix. If I were in Cancun still down in Mexico, I would be right at noon right now. So me and the wife were down in Cancun for a week with some of my wrestling buddies, and then also we were down there training, and then we did some catamaran, went out to an island of mujeres. It was fun. Mujer, it's women in Spanish. Mujer. All right. Anyways, where I'm going with this is this data to mask properly needs to be changed or concealed in such a way that if somebody had the complete data over here, they could not recreate what the data was based on what's going on over here. Like you don't want, like if this was 55512 and over here this was like 999, I don't know, 56 or something, and then somebody could figure it out or change it back. Masking should just, in this case, delete the data. That data is gone. And in this case, it randomized the data. It didn't change it to 2222, 2223 over here, and then somebody could go, all they did was add one digit everywhere. Oh, that's easy. I can figure that out. You don't want to do that. Go to Cancun regularly. Yeah, it was really nice. Hack the Planet. We were in we stayed in the Vedante. So the Vedante group. Some of my friends have like a timeshare with them, and we stayed in a place called the Grand Lux. We had this platinum badge on we had these little wristbands with the platinum badge, which was like this hotel. I went and looked up what this hotel room was a night, and it was insane. But we had a 4-bedroom. It was 2 kings, and then it was a king in each of the. Anyway, there was a lot of bedrooms. So I'll get some pictures out there. And I looked it up. It was $12,000 a night. One of the rooms we stayed in. Then we had 2 other rooms that were like that. But hold on, because they're members and because they had booked and all that stuff, it was a lot cheaper, obviously. But we went and did. We all trained Brazilian Jiu-Jitsu, so we were down there training at a boxing gym down there. I'll come on again maybe later. I probably won't be on later tonight, but tomorrow before I do labs, I'll show you guys kind of what the trip looked like and stuff. But yeah, we went to Isle des Mujeres. We went on we went to a Cirque du Soleil show down there, which was absolutely fantastic. I don't normally I don't go out of my way for Cirque du Soleil, but it was like dinner and all this other stuff, and we were like, yeah, we'll go do that, and it was fun. The wife had a really good time with it too, so that was good. I'll show you guys some videos from that stuff. In fact, that was the first time. I've been at a few Cirque du Soleils and a few shows in general that are live. This was the first one ever. They said you can record or take pictures of any of this, and I was like, they go, just please don't use flash photography, and I was like, that's really cool, because I've never left one of those things and had like a video of everything or whatever. Hack the Planet. I have not really messed with OpenShift much. No, I've seen some white papers on it and whatever, but I've not done anything with it professionally. Yeah, Robedon, we were all in the king bed. Can I tell you though, that bed was so hard compared to our bed. When we laid down last night, me and the wife were like, we were so glad to be back in our bed. And because I was wrestling, I was so sore laying on like this bed that basically amounted to a board. All right. Data in use masking. Then we've got data in motion. So TLS 1.2 and 1.3 are kind of the standard. Here's TLS 1.2 on the left and the more efficient TLS 1.3 on the right. And what happens is they communicate by sharing certificates. So there's always a trust. You always have to trust somebody. And what happens is, how would I know as a client that the server was who it said it was? How would I do that? Well, if I trusted some third party, they could introduce us. And you say, well, how do they introduce you then? Well, the way they introduce us is through a public and a private key exchange. And I'm going to show you guys that here in a second. But suffice it to say here, there's a little bit of a communication. This is the older model. This is the more efficient one. And once we verify that they are who they say they are, we calculate a symmetric key, and now we have a secure channel. But let's go look at, we'll go look at that here in a second, how this communication occurs, because this is important to the process. Again, if you need to know more about X509 certificates, there's the book, Solving the Bottom Turtle. And we showed that, I linked that earlier for you guys. So if you guys look at that. Okay. So encryption techniques, let's talk about this real quick. Encryptions are based on ciphers. Plain text passes through some cipher and you get ciphertext. That's always the rule. You pass ciphertext through the correct cipher again and using the correct method, and you get plain text again. So we put it in one way, it becomes a mess. We put it back in the other way, or whatever the tooling is, and we get it back out, right? Symmetrically, to do that, we use the same key on both sides. It's a one-way process in and the same process back out. Asymmetric is different. It is going to be, when you run data through it, a public and a private key pair. And if you encrypt something with the public key, you can only decrypt it with the private key. And if you create some data with the private key, you can encrypt it, or you can decrypt it with the public key. Now, here's the thing. Depending on where we're using it is depending on which one you actually give out and which one you don't. General rules, your private key never is given out. That's like the general idea. Private key always stays private. Public key can be shared far and wide to the world, right? It's public. For SSH, you hold the private key, and then the server stores in the authorized keys file the public key. We have a lab on that that shows how you create the key and how you push it, but it suffices to say it looks like this, right? On this server here in root.ssh, I have an ID underscore RSA. I would never, in all the world, show that to the stream or anybody. And you might say, really? You wouldn't? Like, well, what if they just wanted to, you could stop the video and you could copy it out, and it would actually be a danger because that key should never be shared with anybody. Learn well, but you do become extremely valuable. Yeah. Hack the planet. I agree. I think this is something that takes time, but after you learn it, it's valuable. And I think OpenShift is pretty valuable too. We moved away. We didn't do. Actually, OpenShift was used at AAA. They use OpenShift, and my brother Johnny helps manage it. He was in charge of managing it for a while there, but I think he moved just over being a middleware engineer. So he just kind of makes sure that everything's working. But now look this. I will show you guys the ID underscore RSA.pub. Because I can share this far and wide to all the world. In fact, I'll show you how I shared it far and wide to the world. I can go to Hostbox. And if on Hostbox, as the root user, .ssh, right? And then if I go more authorized hosts or authorized keys, this is the same exact key right here as this right here. There's two reasons I know that. One, I just got in the box using this key. And two, I can look at them and see that they're the same. Right? Looking for a viable alternative VMware via OpenShift and air-gapped networks to manage VMs. Yeah. Yep. There's that's definitely OpenShift is the reason that AAA could use OpenShift so much is for the platform engineering teams to be able to support about 200 dev teams. It's easier to allocate and do resource management through a tool like OpenShift than kind of a lot of the one-off tooling that we had built around it. And we were good. We were using VMware's VRO and VRA, which are their virtual realize orchestrator. And I never know what VRA is, but it's basically their little like you buy stuff. It's like a catalog tool. VRA ends up being a catalog tool. I don't know if that's all it is, but VRO. Yeah. So, anyways, I can see moving away from that. Especially, my understanding is VMware has recently like doubled or quadrupled their price for a lot of their customers, which makes sense because they were recently bought too, weren't they? Yeah, VMware was bought by somebody. All right. TLS, the server holds the private key, and you, the client, your browser, downloads the public key from a certificate authority who you trust. That's very important. But let's look at what that process looks like for asymmetric key encryption. All right. So real quick, it's SSL or TLS, but SSL really shouldn't be used anymore. Even back as far back as like 2017, SSL was deprecated. And then you were supposed to use at least TLS 1.1, but now we're at 1.2 and 1.3. So really you want to be up at like TLS 1.3 right now. SSL should be deprecated and removed everywhere you find it. You shouldn't be using SSL, right? But there's two things it does. It ensures the authenticity of the server. That's called non-repudiation. You can't say that I wasn't talking to you. I know that you are who you say you are. And two, I know that you can't come back later and say, you did that transaction with some other server. I'm like, no, I definitely know I was talking to one of your servers. Or your private key has been compromised. That's the only two options that could happen. Yeah, it's all TLS now under the hood, Wendy. Yep. And then it can encrypt the data between the two endpoints. But why? By the way, I said right here that once we calculate, so once we do this in an asymmetric. So hold on, let me pull this up real quick here. I want to pull this up real quick for you guys. So this up here, this is asym up here. Right? Asym, like I was just saying. And then down here is all symmetric. So how do we know that those are symmetric down here? Or why does it matter that this is all symmetric down here, and why was it okay that it was asymmetric up there? Switch to OpenShift would save about $4 million per site for a business. Definitely worth a look at. Hack, I think that's definitely the case. Somebody before you came in was talking about they were talking about OpenStack, which is different. But yeah, OpenShift is definitely valuable. But then you're more in bed with Red Hat, so it depends on how some organizations I've watched kind of decouple from the Red Hat stuff recently. So I think that's going to be a project we're going to be working on here with the ProLug, like engineers that want to hang out and do a little more than others. Because, you get as much out of any of our groups as you want as an engineer. But if you're very involved with our professional Linux users group, we have like projects and stuff that we kind of do. And one of the ones I'd like to do would be kind of deploying some of these things up in the cloud and making it easier for like the deployments and stuff. And we have a few AWS solutions architects that do that stuff professionally. I just do it, for fun and get the certs for fun. Some of those guys go and get those certs or are actually working for AWS. We have a few people over there. That's exactly right, Stefan. So Stefan over on the AWS side said, or on the YouTube side said, so asymmetric, and then symmetric is all the data all the way down to the bottom. And here's the thing. Symmetric encryption takes about 1/10. About 1/10. That's an H. the processing power. So asymmetric is very processor intensive. So we only use it to introduce each other. We use it to introduce each other and agree on a symmetric key. Then we jump over, and all the keying afterwards is symmetric at about 1/10 the processing power needs of if everything was done in a symmetric way. So that's it. If you've ever wondered, why the hell, why can't we just do one? Well, because one is very useful for trust authorities. We can go to a certificate trust, and I'm going to show you guys here in the next slides. We can use that to verify they are who they say they are, because I trust that, and that thing provided them the private key that only they have, and I have the public key that only I could have, and I'm going to send them a message, and only they can decrypt it and send it back to me. Boom, we're good. If you want to learn more about cloud, does it matter generally which cloud you study between GCP, Azure, or AWS? I don't think it does, Psi Gamma, but I will tell you, I think I like AWS. Also, we have a tremendous amount of resources on our server around AWS. I have a few Azure architects that I know professionally and as friends, but I can't get them involved in our Discord server. They just won't. I don't know if they're just too busy doing other crap, but the AWS guys are always down there hanging out, talking. So I'm a big fan of AWS. We do have a few guys that went and got their GCP certs of different types. We have some GCP architects. I think if Chicken's ever around, he's got 5 or 6, I think, of the GCP ones. So he went and got a lot of those. And then he's been out a little bit for personal reasons, but he'll be back. He's around every now and then as well. And you'll see him sometimes if you're in the Discord. You'll see him pop up playing video games and stuff. And he's one of our. He does stream, although he's like how Fisherman is and Sending. We need them to stream more. Also, Salty Catfish. All those guys. I need them to stream more. I'm always telling the guys, get on their stream. Like, these people want the kind of stuff that you guys know, you know. But everybody gets busy, so I don't blame them. All right. So yeah, that's exactly how it works. But let's talk about this handshake, right? So this handshake happens, but what's happening like under the hood? And that's down here. So we talked about this. And then for TLS, the server holds the private key. Then you, the client, download the public key from the certificate authority that you trust. So that happens, we talked about this, happens right here. So here's the certificate authority. They verify the company's server before issuing an SSL TLS certificate. Then your server holds that certificate and that private key real tight. Never lets anybody see it. Then you come in and you want to connect right over there. So you go to the certificate authority and say, hey, I want to connect. I want to be introduced to this person. So go ahead and give me the public version of this server's certificate. And they'll give you the public version of it. And you're good. So now you use that public key, right? Use that public key to send a little message over to that server. This is all what's happening in this handshake right here. You send a hello over, and the key exchange and the cipher right here that happens, or here where they do a key share, what's going to happen is you're going to say, well, it could happen either way, but most protocols, you're going to encrypt something and send it over to them, and they're going to decrypt it and send it back. Or your server could alternatively send a string, it would encrypt and send it back, and then you would know that it was the same. They could compare, right? But the point is, either way that happens, I believe the way it technically happens is we encrypt over here and we send it over and they decrypt and they send it back to us. And then we go, yeah, that is the message I sent you. Okay. It's some random string, or it can be a configured thing or whatever, but it comes back as what you expect. And the only person in the cryptographic space that could have taken your ciphertext and turned it back to a plain text to send back to you, the only person that could do that was whoever had this private certificate. That's the only person that could do it. That's the only server that could do it, right? And that's how I then, since I trust the certificate authority, and you derived your persona, or whatever you want to think of it as, your identity from that, I can trust, after having been introduced by that certificate authority through the cryptographic process of me using your public key to connect to your private key. That's it, right? Then all the other things happen. So that's all the pieces of it. If you've ever wondered kind of how that works, that's pretty much it. All right, let's talk compute security a little bit. And I only have a few more minutes because I got to get off here and get ready to talk to my college students. Compute security, some things to do when you're looking to protect resources out in the cloud. You want to make sure that you plan your subnet placement in the AWS space, which I know way better than either of the other two spaces. You want to think about what needs to access the internet and what doesn't. What needs to be able to move. Can I use SSH over TLS PKI? You can actually connect to SSH using certificates if you wanted to. Yeah, you can do that. I'm sure there's tools that'll do that. One of our guys uses that for everything, Stefan. If you're in our Discord, there's a guy, Inspector, and he does that. He uses his public key. Actually, he uses certificates for everything, not even the keys. But anyways, okay, so plan your subnet placement. Think about where data needs to flow, what does need to have an internet gateway in its routing table, and what doesn't. And then you're going to figure out those kind of things. Disable the unneeded ports and services. If you're not using port 3389, which is remote desktop protocol for Windows, there's no reason to have that open, right? SSH port 22, that needs to be available if you're going to connect. But if you're not wanting to connect, some people, there's a whole push in the cloud to not allow SSH or RDP connections. So we block these. Or if we are going to allow them, we don't use something like a wildcard to everybody. We only use our internal address spaces of whatever our company uses. Well, it would be our external address at that point, but only those ones can connect in on these ports. Or we don't allow these at all, and we use some other management tool for pushing data up there, like Systems Manager inside of AWS. There's other tools for the other things as well. And then enforce account management policies. These are huge. This is part of PCI compliance as well. Deactivate any default user accounts. Change passwords that are default. Do not expose any ports that shouldn't be allowed. Those kind of things. That's all the firewall stuff. But deactivate default user accounts. Require best practice account management policies such as password complexity. And even if you come in as a user, your least privilege access, and then you have to sudo up to get root permissions. Even if your user has permissions, they still have to sudo up with a key or a password to get up. Yeah, and I say if we're being honest, passwords are out. Certificate or key-based connectivity is best. Then you need to update or install antivirus software. This is actually a PCI standard nowadays. So for Windows, you can use Defender. For other OSs, you need to have antivirus running. In the Linux space, even though I hate it, I have turned on firewall or antivirus. It tends to be Clam antivirus, which you can build automation into, or CrowdStrike. By the way, Clam antivirus is still open source, but do you guys know who owns it? Cisco. Cisco owns Clam antivirus, so don't be surprised if one day that's not open source anymore. Install host-based firewalls. Make sure you turn on your firewalls and only allow the things through them that they should. There's a lab for this on our Killer Coda. There's a lab for this. There's a lab for some of these things, and I need to do one for the we do some hardening and stuff. So these four, there's some labs for those on our labs down in over on Prolug Labs. So yep. Okay. VPCs. So how does a VPC subnet work in AWS? So has anybody ever told you guys, or have you ever thought about the difference between a public subnet and a private subnet? What if I told you the only difference between a public subnet and a private subnet was whether or not the router that's connected to it, there's a routing table connected to all your subnets. If it has a route to get to the IGW, which is the internet gateway, it is a public subnet. If it does not have a route to get to the internet gateway, it is not a public subnet. Now, could I have this be a private subnet over here? Have these devices here connect over here to a device that's running a SOCKS proxy. Remember I talked earlier about having like a SOCKS, or nowadays very popular to have like a SQUID proxy. And then this SQUID proxy goes to its gateway or its router, and its routing table has a gateway entry, and it goes here and goes out. Yeah, you can have that. That would be a NAT, a network address translation. Even though it's just a SQUID proxy, that's still the same concept. It's a network address translation. There's tools that'll make that easier for you. But by and large, again, over the top, before we go into all the little nitty-gritty stuff, a private subnet does not have in its routing entry an internet gateway. Let me prove that to you real quick. Let's go back to my AWS real quick. So if I go back here and I go into my AWS console, I think mine's still logged in. Let's see if mine's still logged in. Let's go to my VPCs. Let's go look at my VPCs. Hey, thanks for the follow. Hopefully this stuff's useful to you. It's funny, on the YouTube side, I don't see if anybody follows while we're talking here, but they call them subscriptions over here, and then it's all weird. But watch this real quick. This is actually a cool tool. This only came out a little while ago. By the way, you guys know you can look at your AWS in dark mode, right? Let's go to my, this was from one of my college classes. I built this one. And I built it, I think, while we were sitting there talking. Let's go to one of my bigger VPCs. All right. Here's one of my bigger VPCs. So here's my subnet public and private. But if we look over here at the right, the top is the gateway. That's up there on the top. That's my internet gateway, IGW. The only things in the routing table that can get to the project IGW are the public subnets. Do you guys see that? This is a really cool visualization tool that they added within the last year and a half for sure. Speaking about Cisco products, do you personally prefer Cisco, Fortinet, or Palo Alto? Wendy, I don't have a preference on them. I probably have worked with more Cisco in my career, and then I have, in my recent 10 years, I have done 90% InfiniBand and probably about 10% Cisco. So I haven't used Fortinet or Palo Alto really at all because I haven't been on the networking side of things for quite some time. In case anybody's unclear, I am very much like a Linux platform, high-performance compute type engineer, automation engineer. I don't do a lot of networking anymore. I still have a lot of networking knowledge, but I don't, strictly speaking, get down in the networking unless things are broken over there. Just so you guys know. Yeah. And Adish Singh, hopefully this stuff's useful to you. Thank you over on the YouTube side. So I'm just showing you guys this. And then we go into the routing and how subnetting works in other talks, right? But anyway, so subnets, and then these were the things I was talking about. Plan your subnet placement. How do you want it to look? Disable unneeded ports and services. These are all the things that were just on the last slide. Enforce account management policies, so how people connect to your system. Install host-based firewalls. At the bare minimum, use things like your subnet, what do they call them? Whatever those filters are. Hold on, where are they at? I got them right here. Security groups. Security groups are kind of like your firewalls. So security groups actually get attached to what's called your ENIs, which are your elastic network interfaces. It's weird to think about it, but if each of these are your actual AMIs, your Amazon Machine Images that have been stood up into EC2 instances, they all have a ENI associated with them, an elastic network interface, and that elastic network interface gets connected by the subnet that it's in to this right here, to one of these, which is called a security group. And that security group is a state-aware, it is stateful connection on that elastic network interface as though it were like a firewall. So you could have, in the AWS cloud, you could have an actual firewall at the network level. You could have a security group acting as a port-based firewall. Then you could have a firewall on the device, and then you could also close ports off. So you have multiple levels of depth to the things that you can do here. And if I go click on any one of these, this one simply lets all traffic in and out. Kind of wild. Probably shouldn't have that one. And then install and update your antivirus software on each of your different processing EC2 instance type things. All right. So troubleshooting, cloud security. These are the things that you really want to just snuff these out early on. Unencrypted data communications, you don't want to be doing that. You need to have you're going to have inside of AWS, you have a certificate manager, and then you can just generate certificates right here. And then you got to go place those certificates. So look, here's my certificate manager. If I want to go just start generating certificates in here, I can request certificates and then put them on my web pages or in my servers or whatever. There's a bunch of things. I can generate my own certificates so that I keep all of the original material, and then they're just managing it for me. And then in that case, I'm the one who controls the certificate authority as opposed to trusting them, right? There's different levels to this, and it also depends on the security posture of your organization. What's acceptable? There's different levels to all of this stuff. All right. Weak or obsolete security technologies. Don't be using SSL. TLS is the standard now. All right. So it's something to think about. Incorrect hardening settings. Guys, if you're just going to leave shit open on your servers and you just have things exposed out to the world, people are going to connect to them. They're going to scan very quickly, and they're going to find things that are there. So you need to change default passwords. You need to turn off services that aren't running. Turn off users that aren't supposed to be in there. I've shown you guys before how you can just go look through all your users real quick to see which ones are able to log in or not. This one here. Watch on my main box. If I just did, so if I need to look at the data, if I didn't know the data, cat, Etsy, pass, WD, there's all my users. But if I just needed to see how, if I just wanted like a high level understanding, I could cat, Etsy, pass, WD. I know that there's 7 fields across, right? Awk-F for the field delimiter. And then I just want to print out $7, which is the 7th field. And I can look at that real quick and go, that's cool. And then I take this and I go, with that data, I say sort, and then unique-C. That's how many, there's 34 that can log into this. There's one that's binbashin.sh. There's 50 that are not able to be logged into. And then all these other things also can't be logged into. But I have 34 users in the system that can be logged into as just a basic scale without even going and digging into which users are which. But that's a quick way to kind of use a little bit of Linuxy bash, right? A little bit of command line stuff. Hey, it's Hap. How's it going? We're just hanging out here talking shop on both the Twitch and the YouTube side of things. Talking about, I'm kind of showing things as beginner to enterprise, right? Like starting out as just beginner doing this stuff, getting you guys kind of the tools and the terminology and the things that you need to go do this, right? Security device failures, you have to have failovers and redundant systems to minimize the impact of those events. We were talking about that earlier, the uptime and how we could just have things be redundant, but without all that cost of building into some of those other tools. You could spend a lot of money on one system, or you could just build a separate system next to the one and have pretty good uptime, Encryption issues, make sure that your keys are kept in protected, isolated environments. If you ever have a key that is ever compromised, you immediately blow away everything generated by that key and change out your keying system. And there's ways to do that in the cloud where, you just say, hey, I revoke all the keys generated from this key, and then you have to regenerate it and redo it. Now, that sounds like a lot of work, right? And it is. But this is one of the reasons we use key management servers and key management systems, because I can then go have the key management system wipe everything and clean it out. And then the users coming with new requests are going to that key management system, getting that new key and going through the whole process. And when I say users, I could also mean service accounts or applications. They do not deal with the security side of things. It is secure by what we call secure by default. We build the security into the system so that the tooling at most could just have a little blip of not being able to connect anymore because they're using an old key, but then they go get a new key and then everything works again. But they still have to go to that tool, right? You can tell if a key is compromised. Well, Robodom, there's a couple ways. One, if it's ever been, we rotate them over time. We just consider that entropy of a key is eventually going to be compromised by the fact that somebody could have gotten a hold of it and changed it. If the key ever has the wrong permissions, if an administrator ever leaves your organization, those are all ways that we just assume the key is compromised. Doesn't mean it was compromised. We just assume it was. We do audit logging, Robodom, to make sure that users are logging in. Like maybe in my case in my home lab, I only ever expect P01 Jump 01 to ever jump into Hostbox. So if anybody else ever jumps in, even with a key to Hostbox, it alerts me. Those kind of things, right? I have a lot of things that alert me in my environment, but that's one that's big to me because I know anybody that knows how to get into my environment comes through Jumpbox and then goes up, right? Nobody goes directly to that server ever. Doesn't make sense. The workflow doesn't even make sense. So if somebody did manage to get in there, even though that's turned off in SSH, they should only be able to get in that one way and it would alert me. So, all right. Migration planning. Security as a foundation is easier than security as an afterthought. I want you guys to think about this. If I came out and I was a waiter at your table and I poured water for everybody, and then I came out and I gave you bread and you guys were sitting there munching on the bread, and then I walk over there with a tablecloth and I'm like this, I start trying to put it under the table, like between, could you imagine that? Could you imagine a waiter like doing that? That sounds like something Mr. Bean would do, right? This is actually my glass cleaner. But Could you imagine that? It would be a mess. One, it wouldn't work. Two, it would probably just frustrate everybody. But that's trying to do security afterwards. Oh, I get, yeah, I have it a couple ways. I get alerts to our Discord when things like that happen. So like with webhooks, we use webhooks. Yeah, I could set it up for text messages. I've never done that though. I always just send that, and I send out to like Teams channels at work. So I get alerts at work too for work stuff like that. But these are all the things that AWS says to do. Implement a strong identity foundation. You don't have that external powerful wall anymore like you did when you physically had your business. All right? When you physically had a data center or whatever. Enable traceability, monitor, alert, audit actions, keep track of everything. Right? And if you know certain behaviors, you can stop them ahead of time, which is what we call signature-based tracking of things, right? But enable traceability so we can see what's happening with the system. You can't do anything. I tell people all the time, right? Like this is what we do in the Linux world. This is what I got right here. Look at this. Whoops. That's what I got right here in the Linux world. This. Software I use for traceability, I use like Node Exporter for a lot of my metrics. I use Promtail for my logs, and then I use Telegraph for kind of like some of the traceability stuff. Up in the cloud, I use X-Ray, AWS X-Ray, but those are the things that feed data over into. Hold on. It's never a problem, but this is just for people that haven't been here. This is what my logging looks like in my home lab. Oh shoot, I don't have it open. Yeah, shit, I think I have it here. Hold on. Excalidraw. Let's open it up in Excalidraw. Open. Yep, load from a file. I don't mind replacing. Where's our monitoring? Here's our monitoring. Yeah, here's our monitor. Here's the ProLug lab monitoring architecture. This is how my home lab works right here. Any one server has Telegraph, Promtail, and Node Exporter on it. I try to keep the amounts of agents on Linux boxes down as best I can. But for the home lab, we wanted to mess around, so we built a lot of this out. By the way, all these monitoring types here, we have labs on up in Killer Coda that teach you how to build them. So, but this is how I track things. And then Grafana does all my monitoring. But I found out at the beginning of this stream that my monitoring is broken right now, as I just got back from vacation. So the only thing we can monitor is our logs right now, and our Ranger dog. There's Ranger downstairs. Anyways, so that's how we do it. By the way, fun fact for you guys that don't know or haven't been around for this. Did you guys know that with Excalidraw, I can share this right here, and I can start a session, I can copy this link, and then I can drop it in both the YouTube side over here and for you guys over here on Twitch. Now, it's got a comma in it, so you're going to have to copy it and drop it out. But if you wanted to, you can actually be in my Excalidraw right now. You could actually jump in right here as a user with me in Excalidraw. And then when you're done, and by the way, you can change anything you want because I have this saved, then you can also save a copy to your own machine. So then you would have this same one as me. And if it looks weird to you, you got to go here and change the theme to dark mode. So if any of you guys jump in there, you got to go to dark mode, and then it'll look right. I do have Telegraph running as root, or actually no, Telegraph's running as Telegraph. My environment. Yeah, so one of the things you do is you have like a Telegraph user. Certain applications will do this natively, like Telegraph. Sometimes you got to go write this stuff yourself, but check this out. So if I come here and I go sudo -l-U Telegraph. So if you were to compromise, all right, so somebody's able to draw. You guys are seeing. Telegraph does not have the ability to do anything in my environment except do fail to ban status and fail to ban client status, so it can read data out. So it feeds up my Telegraph data to my InfluxDB and all those kind of things. What's going on over here? I always wonder what's going to go on up here. But anyways, yeah, this is you guys. You guys can draw on this, and then you can save it for yourself. Yep, there you go. All right, I got to get off there. I can't leave that up too long, because what happens what happens is if I leave that up too long, you guys still have it though. Anybody in there should still have the access to it, and then you guys can just save it down on your own machine. Anyway, so that's that. Apply security at all layers. Again, defense in depth, because we expect things to be compromised. Automate your security best practices. So I build security in. Remember I was saying earlier, I build 100 servers and they all come out 100 the same. That's a best practice. And then I build my security in there so that all my trust models are built to whatever Active Directory or whatever I'm trusting, and all my deployments of all my PAM, which is my pluggable authentication module, all those things kind of happen. But man, I tell you guys, like people look at the stuff that I build and they think it's complex. But guys, I do very simple things. Well, yeah, I use Ansible a lot. So I got my Terraform cert like just over 3 years ago, and then I never really ended up using it at SAP. So I have Terraform in my home lab projects, but I don't use I haven't used Terraform professionally really much ever, except to do some deployment tests and stuff. Ansible I use professionally against right now 6,700 servers right now is how many I hit with Ansible. And if I go over to this NASA project, it'll be 16,000 over there, and then another, so like 22,000. But that's one of the things that I'm good at. I'm pretty good at building inventories. I'm actually, I would say, really good at building inventories, and then really good at like rapid deployment of things with Ansible. That's something. And I have a bunch of labs on Ansible to show you guys too. Not right now, but. Protect data in transit and at rest. We talked about this. Classify your data into sensitivity levels. Again, I said this earlier. If you just have a bunch of data, it's very hard to hold all that data. But if you put that data into buckets, it's easier to control which bucket's the most important, which bucket, I want to spend the most time and effort on, and that kind of stuff, right? Keep people away from your data. That's true. Make data immutable. Event data has to be immutable. Event data and logging data should happen and be gone so far away from where they're happening that even if somebody wipes that box or destroys that box or whatever, we still have all the data. So data always needs to be pulled off the server in real time. And then prepare for security events. You got to practice. I have some stuff on events and security monitoring and those kind of things that we'll talk about in some of these other ones. But yeah, have incident management, investigation policy, and process aligned with your organizational requirements. Run incident response simulations with tools and automation. So I have some tools. There's a really good card game that was built by Black Hills Security called Backdoors and Breaches. And it's just super useful for talking through what procedures do we have, what don't we have, what are we doing in all these different scenarios. And I'll do that again on stream one of these days here, especially since probably a lot of the people on the YouTube side haven't ever seen it before. So I was telling you guys, I only recently... we had one video on YouTube that got like 50,000 views or something. So like popular is relative, but when I'm used to only having like 2,000 total views, then 50,000 is kind of big. And then I was in Mexico for a week, so I watched that like all cool off. And this was my first stream back. So I've been telling you guys like, hey, we're going to try to keep this going, try to get more people involved with Linux. Again, the Discord is there for you guys to kind of hang out and talk shop with engineers and that kind of stuff. All right. And then here's our review. We talked about protecting data security with the confidentiality, integrity, and availability model. We talked about defense in depth, and components of pieces will always fail. There's a little paper clip sitting on my desk. You guys know this paper clip will eventually fail? And you say, what do you mean, Scott? You can't just put some paper in there and leave it for years? Yeah, sure. Maybe it takes 100 years to fail, but it'll fail. This, if I had sneezed earlier into like this little napkin, it would eventually fail, right? And your systems are gonna fail. That's actually a rule of the cloud. Is like, we know, this is a rule in data centers. I know systems are gonna fail. That's why I use RAID, redundant array of independent disks. It used to be redundant array of inexpensive disks, but people equate inexpensive to cheap, so it's redundant array of independent disks. We know components are gonna fail, so we plan for it, right? Because we want that durability of our data. So defense in depth is the idea that we understand that no system is perfect. No system is unbeatable. So when you defeat a system, you find two systems behind it. And you defeat one of them, you find another system there. And it's just to slow people down. Eventually, people get to your data. Eventually, your data gets leaked. And in a lot of places, it's an inevitability of getting attacked over and over again. So we just try to slow them down and protect the data in ways. It's a cat and mouse game, right? In a lot of ways. So defense, data at rest, data in motion, and data in use, that's when we encrypt. Compute security, we talked about protecting the compute resources behind layers of network security, hardening the device, only leaving ports open that should be, only allowing access to those ports from devices that should connect to it, all these kind of things. Talked about encryption. Symmetric means same key on both sides. Typically, when you see PSK, pre-shared key, it means that I told you the key out of band, so the key never travels over the wire. What that's like is if your friend comes over and says, "Hey, can I have your Wi-Fi access?" and you go, "Oh yeah, it's Crunchy Man 2024 or something," and they're like, "Oh, that's a weird password, but okay." That was an out of band. That wasn't sent over the wire, and then they get that pre-shared key from you, and then they can access the system and communicate, right? Make the attacker's life harder, weed out the script key. Yeah. The most dangerous one to most of us is the persistent threat actors. Persistent threat actors are massive problems in the industry in general. But like the bots and the script kiddies, they're just out knocking on doors. They're just like a person walking through a parking lot checking for open door handles. I mean, think about this. If somebody's just checking open door handles, are they actually breaking the law? I mean, if they're opening the door and taking stuff out of the car, of course they're breaking the law, but just checking door handles for if a door is open? Anyways, that's what bots are doing. Bots are literally just walking around the whole internet, scanning all the ports up and down. And then if they find an open port, they just start knocking harder, knocking more, trying to get into the glove box and trying to get at whatever. So, okay. So asymmetric, symmetric, SSL and TLS, what are they? They are encryption ways to pass data securely and to verify that somebody is who they say they are, right? And then troubleshooting cloud security. What are some common issues? There's a bunch of them. Build security into your deployment. Don't try to slide it in there later. It's not going to work. And then visibility is the key. Make sure that you can see what's happening in your different environments. Not like me, where I just pulled these up during stream and they were already busted with all the I don't know. Oh, what's going on? These things have all been up. All my servers should be. Oh wait, hold on. Did I go to? Oh, that's my problem, guys. My problem is I'm on the old servers. That was my fault, guys. 218. So hold on, my stuff's up. That was dumb on my part. Hold on, my system's up. So I have 2 Grafanas. Yeah, okay, hold on. My system's up. I was sitting here thinking, like, what the hell is going on with my security and connectivity, and then logs and apps. So yeah, these are all working still. Yeah. So I was being dumb. I was connected to 219, which is my old one. How do I handle updates, or is it managed cloud? So there's 2 ways it's happened that you can do updates. There's two kind of generic. There's two general or generic. I'm looking at the closed captioning to see if it's actually talking. Sometimes I look down that closed captioning and it's nothing like what I'm talking about. There's 2 ways I handle updates. Either on a stateful machine, I update the machine, reboot, and bring it back up. So that's like yum, apt, DNF, zipper. These are the tools that do those updates. I don't know what they are in like Apple, but in Windows, they would be like Windows Updater. Update the server, bring it down, bring it back up in place. That's a stateful type server update, right? Just update whatever's there in the repositories. The repositories are things that you trust out in the world that your server either came with or used to sign later, places that it goes and looks for repos, it downloads the metadata, it finds out if it's got the right PGP signature from the PGP key that you trust, right? We do that in some of our different labs too. That's one way. That is for stateful machines, meaning it's like a big fat server that's sitting there. It goes down, it comes back up. It's like, I'm still a server. Good. Stateless servers, this is the other way you can do deployments. Stateless servers work like this. They exist in a perfect form from start to finish. Meaning, when I have like a RHEL 7.9 and I want to go to a RHEL 7.10 server, I do not touch the server deploy. It's good. And over here, I work on building a RHEL 7.10 deployment. and I test it, and I bring it up, test it, I'll destroy and deploy this server 100 times, dude. And when it's perfect, I turn off this 7.9. It'll never come up again as a 7.9, and I deploy it as a stateful 7.10. And that server will sit there as a 7.10 server that's never updated, never changed, in a stateless environment. And if he ever gets like a web server put on him, and then I turn him off and he comes back up, that web server's gone. Because he has come on as like a net boot from like a... It comes up as like a squash FS that it's downloaded each and every time. And it's exactly the perfect original machine every time. No updates are ever done in place. So with stateful, we just update the server in place until its useful life, typically 3 years or less, is done. And then we destroy the whole server and rebuild it as another big fat stateful image of like Rel 8. Or over here with stateless, we just build a new type of server, and then we do almost like a blue-green deployment between them and just bring the new one up. So that's a really good question. And if you want to see how some of those deployments go, AWS has some pretty good blue-green deploy versus Canary, in fact. Blue-green deployment inside of AWS was right here. So I like the PDFs, so I'm going to send you guys the PDF side of it. I'll post it there, and then I'll post it over on the YouTube side for you guys as well. So there's that. All right. Guys, I have to get off of here because I do got to go run my college class here in a minute. But if this stuff's useful to you, please, like, follow, whatever. Those things are all free. Subscribe on the YouTube side. You guys are free to do that. If you want to go talk with other engineers that are talking about the same stuff as you, that's what Discord is for. Discord is just a free resource out there for you guys to hang out, talk shop. I'll be down there later, but I'll be watching it, all the time. But I've got mods down there and people that are pretty good. Yeah, Wendy Force, I appreciate, like, people think, like, I get told this all the time. They're like, I didn't mean to distract you, and like then I'm all spinning off in different directions. And I'm like, I actually prefer that. Because I know from being a college professor for 15 years that I will just brain dump. And I know that somebody's got a question, and I would prefer the question and then kind of move from there, if that kind of makes sense. So, guys, we got a lot of stuff out there on the Discord. We got a lot of stuff on YouTube. I'm trying to get it more set up so I have it real organized so people can do the individual labs and stuff. So look for those to be popping up on there. But I do appreciate it. Also, I really appreciate Robodom kind of managing everything for me. He's kind of become like my across-the-board moderator of everything. So I definitely appreciate that as well. So, yeah, if you guys have questions, ask them down there, and we'll be back on. I will be back on tomorrow for sure, and it will be all labs on Sunday. That's all we do on Sunday is labs. Yeah, yeah, Robodom's getting double. Robodom, you can have 10 times your current rate. All right, cool, guys. We will talk later.